Welcome to the NumPy for Data Analytics Full Course by Simplilearn. NumPy is an essential Python library that powers fast and efficient data analysis by handling large numerical datasets with ease. It's specially designed for working with arrays, enabling complex mathematical and statistical operations that are critical in data analytics. In this course, you will learn how to leverage NumPy capabilities from basic array creations and manipulation to advanced techniques like slicing, reshaping, and performing statistical calculations. You will see why NumPy is faster and more efficient than traditional Python lists when analyzing data. We will guide you through practical examples and real-world use cases, helping you master the skills you need to analyze and process data effectively. So get ready to unlock the full potential of NumPy and elevate your data analytics skill. Also, if you are interested to supercharge your career in data analytics, the Professional Certificate Program in Data Analytics and Generative AI by ENICT Academy IIT Guwahati is the perfect choice. This 11-month live online course offers interactive masterclasses by IIT Guwahati faculty and industry experts, combining cutting-edge tools like generative AI, ChatGPT, Python, Tableau, and SQL. Experience hands-on learning with real-world projects and immerse yourself in the campus environment with a series session at IIT Guwahati. Plus, earn an executive alumni status from IIT Guwahati and IBM recognized certifications to stand out in the job market. You can check out the course link from the description box below and the pinned comment. So let's get started.
Companies around the world are generating vast volumes of data every hour. This data could be in the form of log files, web server and transactional data, as well as various customer-related data. Also, data is being generated at a rapid rate from social media websites and applications such as Facebook, Instagram, Twitter, and WhatsApp. Companies want to use this data to derive value out of it and make business decisions. That's where data analytics comes into use. Data analytics is the process of exploring and analyzing large datasets to find hidden patterns, unseen trends, discover correlations, and valuable insights to make business predictions. Data analytics improves the speed and efficiency of your business. A few years ago, a business would have gathered information manually, performed statistical and complex analytics, and unearthed information that could be used for future decisions. But today, that business can identify insights on the fly for immediate decisions. Most organizations have big data, and many understand the need to harness that data and extract value out of it. So, they use a lot of modern tools and technologies to perform data analytics. Some of the tools I will discuss in detail later in this tutorial.
Moving on, who is a data analyst? A data analyst collects, analyzes, and interprets data. A data analyst will convert raw data into useful information. Data analysts are in high demand because every industry uses data analysis. Work of a data analyst. As a data analyst, you will work closely with the raw data and generate valuable insights to help companies decide their future goal. If you like thinking out of the box, you are the perfect fit for this domain. Data analysts help maximize output when it comes to generating revenue, working closely with both business and data. Nevertheless, this field boasts handsome salaries for all levels of expertise. Can you become a data analyst without prior experience? Yes, anyone can become a data analyst if they enjoy solving real-world problems, have a strong background in statistics, and have a creative mind. If you feel you don't have it, you can definitely develop it. So let us know the skills in detail. What are the basic skill sets required for a data analyst? Data analyst must know basic mathematics and statistics, programming skills, machine learning, and also data visualizations tools. So let us know what are the basics that you need to learn as a data analyst. Mathematics. It is always better to know basic mathematics like linear algebra and probability fundamentals. Linear algebra is used in data pre-processing and transformation, which is the critical process of every data analyst. Statistics, a branch of mathematics that deals with collection, analysis, presentation, and implementation. Probability. We know that probability is the study of how likely something will happen, which is essential for concluding. Both probability and statistics are the backbones of data analysis. It is feasible to become a data analyst with only a basic understanding of these three areas of mathematics. But in order to remain relevant and grow as a data analyst, one mathematical knowledge should not be restricted. Compulsorily use some of the tools as a data analyst. What are that? First is Microsoft Excel. It is the most well-known spreadsheet software in the world. It also has computation and graphing features that are excellent for data analysts. No matter your area of expertise or additional software you might want, Excel is a standard in the industry. Its useful built-in features include form design tools and pivot table. It also generates a wide range of additional features that help simplify data manipulation. As a programming language, every data analyst should know Python. It is easy to learn and has a simple syntax. Python is quite adaptable and includes a vast variety of resource libraries that are appropriate for a wide range of diverse data analytics activities. These libraries help in numerical and data computation. The Pandas and NumPy libraries, for instance, are excellent for supporting standard data processing and streamlining highly computational operations. You can also choose between Python or R. R is a well-known open source programming language much like Python. Data visualization tool. As we previously mentioned, data visualization tool is also necessary to become a data analyst. Power BI is a user-friendly interface, makes building interactive visual reports and dashboards simple. Its most vital selling point is its superb data integration. It works flawlessly with cloud sources like Google and Facebook Analytics, as well as text files, SQL servers, and Excel. Tableau is one of the best commercial data analysis tool available. It handles huge amounts of data better than many other BI tools and is effortless. It has a visual drag and drop interface. However, because it has no scripting layer, there is a limit to what Tableau can do. For example, it could be better for pre-processing data or building more complex calculations. You might have heard about MySQL a lot of time. It is a standard language for interacting with databases, and it is very helpful when working with structured data. SQL creates user-friendly dashboards that may present in various data ways since it is so simple to send complex commands to databases and change data in seconds. It has commands like add, edit, delete data. In addition, SQL is an excellent tool for creating data warehouses because of its simplicity, clarity, and interactivity. Overall, I would suggest that to become a data analyst, you should work on programming languages like Python or R plus MySQL to work on databases, adding to that Excel plus visualization tools like Tableau or Power BI. You now know what are the skills are and how it is used. What are you up to in an organization as a data analyst? To create and evaluate the report using automated tools like Tableau or Power BI. To troubleshoot the reporting database environment and reports. Data analyst, you will use statistical method to analyze data sets and spot any valuable trends that may develop over time. Evaluate companies' functional and non-functional requirements. Data analyst assess data warehousing in inspecting and reporting needs. These are all the responsibility of a data analyst in an organization. Coming to companies hiring a data analyst. IBM, Accenture, Capgemini, TCS, Facebook, Amazon, Flipkart, Meta. These are the top companies hiring a data analyst. But data suggests that every small and medium-sized company needs a data analyst. Therefore, demand of a data analyst is in every company. So, there is no need to worry. Job and salary of a data analyst. This is the final part. The salary of a data analyst is high all over the world. When it comes to the USA, the average salary for a data analyst as a beginner is going as high as $70,000 plus per annum. For experienced professional, it is going as high as $120,000 per annum. In India, for a fresher, it is going as high as 8 lakh per annum, and for experienced professionals, it is 20 lakh plus per annum. Such is the demand for data analyst. Now that we have covered every important skill, it's time for you to start working on it.
So, sky's the limit on what you use it for. Let's take a look at types of data analytics. And this can be broken up in so many ways, but we're going to start with looking at the most basic questions. that you're going to be asking in data analytics. And the first one is you want descriptive analytics. What has happened? Hindsight. How many sales per call ratio coming out of the call center? If we have 500 tourists in a forest and you have a certain temperature, how many fires were started? How many times did the police have to show up to certain houses? All that's descriptive. The next one is predictive. Predictive analytics is what will happen next. We want to predict. This is great if you have an ice cream store and you want to predict how many people to work at the ice cream store on a certain day based on the temperature coming up and the time of the year. And then one of the biggest growing and most important parts of the industry is now prescriptive analytics. And you can think of that as combining the first two. We have descriptive and we have predictive, and then you get prescriptive analytics. How can we make it happen? Foresight. What can we change to make this work better? In all the industries we looked at before, we can start asking questions, especially in city development. There's a good one. If we want to have our city generate more income, and we want that income to be commercial based, what kind of commercial buildings do we need to build in that area that are going to bring people over? Do we need huge warehouse cells, Costco sales buildings, or do we need little mom and pop joints that are going to bring in people from the country to come shop there? Or do you want an industrial setup? What do you need to bring that industry in there? Is there a car industry available in that area? If it's not a car industry, what other industries are in that area? All those things are prescriptive. We're guessing. We're guessing what can we do to fix it? What can we do to fix crime in an area with education? What kind of education are we going to use to help people understand what's going on so that we lower the rate of crime and we help our communities grow better? That's all prescriptive. It's all guessing. We want foresight into how can we make it happen? How can we make this better? And we really can't not go into enough detail on these three, because a lot of people stumble on this when they come in and are doing analytics. Whether you're the manager, shareholder, or the data scientist coming in, you really need to understand the descriptive analytics, where you're studying the total units of furniture sold and the profit that was made in the past. Here we go into predictive analytics, predicting the total units that would sell and the profit we can expect in the future, gear up for how many employees we need, how much money we're going to make, and prescriptive analytics, finding ways to improve the sales and the profit so we can sell maybe a different kind of furniture. We're going to guess at what the area is looking for and how that marketing is going to change.
Hello everyone, we welcome you all to this video by Simplilearn. In today's session, we will learn a really interesting topic, that is the top 10 skills to become a data analyst in 2022. In today's digital world, data is being generated by companies and individuals every second, so the role of a data analyst holds supreme importance. So if you're looking for a career in data analytics, this video will help you learn what a data analyst does and the various skills you need to possess to become a data analyst in 2022. Before we get started, make sure you subscribe to the Simplilearn channel and hit the bell icon to never miss an update from us. Let's look at the agenda for this video. First, we will understand who a data analyst is. Then we will understand the top 10 data analyst skills for 2022. Moving on, we will look at the salary of a data analyst. And finally, we will look at the companies hiring data analysts. So now let's understand who is a data analyst. A data analyst is a professional who collects business data from various sources, interprets it, and uses various statistical tools and techniques to extract insights and useful information from it. They acquire data from primary or secondary data sources and maintain databases. They also recognize and understand the organization's goal and collaborate with different team members such as programmers, business analysts, and data scientists to build an effective solution to a business problem. Now, with this basic understanding of who a data analyst is, let's learn the top 10 data analyst skills for 2022. At number 1, we have Structured Query Language or SQL. SQL is a top skill that every data analyst should have. Data analysts use SQL commands and functions to store, process, analyze, and manipulate structured data using relational and NoSQL databases. They also build data models and write complex SQL queries and scripts to gather and extract information from several databases and data warehouses. Some of the popular databases a data analyst should be familiar with are Microsoft SQL Server, MySQL, PostgreSQL, and IBM DB2. The second important skill for a data analyst is Microsoft Excel. Microsoft Excel is one of the most popular and oldest spreadsheet applications for creating reports, performing calculations, and analyzing data. Data analysts need to know how to handle tabular data in Excel, so they should be aware of features like sorting, filtering, conditional formatting, pivot tables, what-if analysis, and functions such as sumifs and countifs. The third crucial data analyst skill for 2022 is data cleaning and wrangling. Usually, the data collected by analysts from various heterogeneous sources is often messy and contains a lot of missing values. So, it is always crucial to clean the data and remove noise, missing, or erroneous elements. It is also important to format data using tools and methods before using it for analysis. They are responsible for data mining as well. The data mined from various sources are organized in order to obtain new information from it. Some of the tools you need to know for data cleaning and wrangling are Excel Power Query and OpenRefine. The fourth skill on our list is mathematics and statistics. Data analysts often work on data for higher dimensions that are greater than 3. In order to interpret such data, they need to be good at linear algebra and calculus. They also build predictive models and statistical models such as linear regression, logistic regression, naive Bayes, and k-means clustering. In order to understand the working of these algorithms, they must have knowledge about statistics and probability. Coming to the fifth important skill for a data analyst in 2022, we have programming. Data analysts need to master at least one programming language, preferably Python or R. In order to work with complex business problems, analysts need to write scripts and user-defined functions to automate tedious tasks. Python and R language provide a collection of different libraries and packages such as NumPy, Pandas, dplyr, matplotlib, ggplot, which data analysts can use to discover trends and patterns from complex data sets. After this, we have data visualization as our sixth skill. Another data analyst job role is to visualize large volumes of data and prepare summary reports and dashboards for the leadership team and clients so that they can make timely business decisions. To do this, data analysts use various data visualization tools such as Power BI, Tableau, and QlikView. Using these tools, data analysts can integrate various data sets, apply joint conditions, sort and filter data, as well create different visualizations using charts and graphs. The seventh skill for a data analyst is industry knowledge. Data analysts should have good knowledge and understanding of the industry or domain they are working in. For example, if you're working in a healthcare domain, you need to know how healthcare analytics can be applied to improve patient care. You should have knowledge about the challenges faced in healthcare and how you can leverage data and analytics to solve the issues. Only if you have strong industry knowledge can you try to improve the business. The eighth skill that is important for a data analyst in 2022 is problem solving. A business deals with several problems on a daily basis. Data analysts should be ready to face those challenges. Data analysts are expected to use their problem-solving skills, work with the team, troubleshoot what went wrong, and provide an effective solution via data analysis. A data analyst with good problem-solving skills can help a business identify current and potential issues and determine a viable solution based on the data it collects. The ninth skill on our list is analytical thinking. Data analysts need analytical thinking ability to break down a complex problem into simple components and resolve these components one by one. It is a must-have skill for data analysts. Analytical thinking includes deciding the parameters that need to be considered for defining data sets, analyzing them from different perspectives, and determining variable dependencies. Coming to the 10th skill among the top 10 skills for a data analyst in 2022, we have communication. Data analysts don't just interact with computers and programs, They also interact with team members, stakeholders, and data suppliers. So, good communication skills are essential. Data analysts also present their findings in front of an audience who might not be familiar with the analytical methods and processes. So they need to clearly translate their findings and insights into non-technical terms. So those were the top 10 skills a data analyst needs to possess in 2022. Do you think we missed out on any skills? Then please put your answers in the comment section below. Now let's look at the salary of a data analyst. According to Glassdoor, the average annual salary for a data analyst in the United States is $69,517, while in India, you can earn nearly 7 lakh rupees per annum. Finally, let's look at the top companies that are hiring data analysts in 2022. Here we have the consultancy and Big Four giant Deloitte and the pharmaceutical company Cerner Corporation. Then we have the tech giant IBM, retail company Walmart, and the e-commerce leader Amazon. To achieve the goals of data analysis, we use a number of data analysis tools. Companies rely on these tools to gather and transform their data into meaningful insights. So which tool should you choose to analyze your data? Which tool should you learn if you want to make a career in this field? We will answer that in this session. After extensive research, we have come up with these top 10 data analysis tools. Here, we will look at the features of each of these tools and the companies using them. So let's start off. At number 10, we have Microsoft Excel. All of us would have used Microsoft Excel at some point, right? It is easy to use and one of the best tools for data analysis. Developed by Microsoft, Excel is basically a spreadsheet program. Using Excel, you can create grids of numbers, text, and formulae. It is one of the widely used tools, be it in a small or large setup. The interface of Microsoft Excel looks like this. Let's now move on to the features of Excel. Firstly, Excel works with the Windows version of Excel supports programming through Microsoft's Visual Basic for Applications (VBA). Programming with VBA allows spreadsheet manipulation that is difficult with standard spreadsheet techniques. In addition to this, the user can automate tasks such as formatting or data organization in VBA. One of the biggest benefits of Excel is its ability to organize large amounts of data into orderly logical spreadsheets and charts. By doing so, it's a lot easier to analyze data, especially while creating graphs and other visual data representations. The visualization can be generated from a specified group of cells. Those were few of the features of Microsoft Excel. Let's now have a look at the companies using it. Most of the organizations today use Excel. Few of them that use it for analysis are the UK-based company Ernst & Young. Then we have Urban Pro, Wipro, and Amazon. Moving on to our next data analysis tool, at number 9, we have RapidMiner. A data science software platform, RapidMiner provides an integrated environment for data preparation, analysis, machine learning, and deep learning. It is used in almost every business and commercial sector. RapidMiner also supports all the steps of the machine learning process. Seen on your screens is the interface of RapidMiner. Moving on to the features of RapidMiner. Firstly, it offers the ability to drag and drop. It is very convenient to just drag drop some columns as you are exploring a data set and working on some analysis. RapidMiner allows the usage of any data, and it also gives an opportunity to create models which are used as a basis for decision making and formulation of strategies. It has data exploration features such as graphs, descriptive statistics, and visualization, which allows users to get valuable insights. It also has more than 1,500 operators for every data transformation and analysis task. Let's now have a look at the companies using RapidMiner. We have the Caribbean airline Leeward Islands Air Transport. Next, we have the United Health Group, the American online payment company PayPal, and the Austrian telecom company Mobilcom. So that was all about RapidMiner. Now let's see which tool we have at number 8. We have Talent at number 8. Talent is an open source software platform which offers data integration and management. It specializes in big data integration. Talent is available both in open source and premium versions. It is one of the best tools for cloud computing and big data integration. The interface of Talent is as seen on your screens. Moving on to the features of Talent. Firstly, automation is one of the great boons Talent offers. It even maintains the tasks for the users. This helps with quick deployment and development. It also offers open source tools. Talent lets you download these tools for free. The development costs reduce significantly as the processes gradually speed up. Talent provides a unified platform. It allows you to integrate with many databases, SaaS, and other technologies. With the help of the data integration platform, you can build flat files, relational databases, and cloud apps 10 times faster. Those were the features of Talent. The companies using Talent are Air France, L'Oreal, Capgemini, and the American multinational pizza restaurant chain Domino's. Next on the list at 7 we have NIME. Constance Information Miner on NIME is a free and open source data analytics, reporting and integration platform. It can integrate various components for machine learning and data mining through its modular data pipelining concept. NIME has been used in pharmaceutical research and other areas like CRM customer data analysis, business intelligence, text mining, and financial data analysis. Here is how the interface of NIME application looks like. Now coming to the NIME features. NIME provides an interactive graphical user interface to create visual workflows using the drag and drop feature. Use of JDBC allows assembly of nodes blending different data sources, including pre-processing such as ETL, that is extraction, transformation, loading, for modeling, data analysis, and visualization with minimal programming. It supports multi-threaded in-memory data processing. NIME allows users to visually create data flows, selectively execute some or all analysis steps, and later inspect the results, models, and interactive views. NIME Server automates workflow execution and supports team-based collaboration. NIME integrates various other open source projects such as machine learning algorithms from Beca, H2O, Keras, Spark, and our project. NIME allows analysis of 300 million custom addresses, 20 million cell images, and 10 million molecular structures. Some of the companies hiring for NIME are United Health Group, ASML, Fractal Analytics, Atos, and Lego Group. Let's now move on to the next tool. We have SAS at number 6. SAS facilitates analysis, reporting, and predictive modeling with the help of powerful visualizations and dashboards. In SAS, data is extracted and categorized, which helps in identifying and analyzing data patterns. As you can see on your screens, this is how the interface looks like. Moving on to the features of SAS. Using SAS, better analysis of data is achieved by using automatic code generation and SAS SQL. SAS allows you to access through Microsoft Office by letting you create reports using it and by distributing them through it. SAS helps with an easy understanding of complex data and allows you to create interactive dashboards and reports. Let's now have a look at the companies using SAS. We have companies like Genpact, IQVIA, Accenture, and IBM to name a few. That was all about SAS. So for all those who joined in late, let me just quickly repeat our list. At number 10, we have Microsoft Excel. Then at number 9, we have RapidMiner. At number 8, we have Talent. At number 7, we have NIME. And at number 6, we have SAS. So far, do you all agree with this list? Let us know in the comment section below. Let's now move on to the next 5 tools in our list. So at number 5, we have both R and Python. Yes, we have 2 of them in the 5th position. R is a programming language which is used for analysis as well. It has traditionally been used in academics and research. Python is a high-level programming language which has a Python data analysis library. It is used for everything starting from importing data from Excel spreadsheets to processing them for analysis. This is the interface of R. Next up is the interface of the Python Jupyter Notebook. Let's now move on to the features of both R and Python. When it comes to the availability of R and Python, it is very easy. Both R and Python are completely free, hence it can be used without any license. R used to compute everything in memory and hence the computations were limited, but now it has changed. Both R and Python have options for parallel computations and good data handling capabilities. As mentioned earlier, as both R and Python are open in nature, all the latest features are available without any delay. Moving on to the companies using R, we have Uber, Google, Facebook, to name a few. Python is used by many companies. Again, to name a few, we have Amazon, Google, and the American photo and video sharing social networking service, Instagram. That was all about R and Python. At number 4, we have Apache Spark. Apache Spark is an open source engine developed specifically for handling large-scale data processing and analytics. Spark offers the ability to access data in a variety of sources including Hadoop Distributed File System HDFS, OpenStack Swift, Amazon S3, and Cassandra. It allows you to store and process data in real time across various clusters of computers using simple programming constructs. Apache Spark is designed to accelerate analytics on Hadoop while providing a complete suite of complementary tools that include a fully featured machine learning library, a graph processing engine, and stream processing. So this is how the interface of Apache Spark looks like. Now let's look at the important features of Apache Spark. Spark stores data in the RAM, hence it can access the data quickly and accelerate the speed of analytics. Spark helps to run an application in a Hadoop cluster up to 100 times faster in memory and 10 times faster when running on disk. It supports multiple languages and allows the developers to write applications in Java, Scala, R, or Python. Spark comes up with 80 high-level operators for interactive querying. Spark code for batch processing, join stream against historical data, or run ad hoc queries on stream state. Analytics can be performed better as Spark has a rich set of SQL queries, machine learning algorithms, complex analytics, etc. Apache Spark provides fault tolerance through Spark RDD. Spark resilient distributed data sets are designed to handle the failure of any worker node in the cluster. Thus, it ensures that the loss of data reduces to zero. Conviva, Netflix, IQVIA, Lockheed Martin, and eBay are some of the companies that use Apache Spark on a daily basis. At number 3, we have another important growing data analysis tool, that is QlikView. QlikView software is a product of Qlik for business intelligence and data visualization. QlikView is a business discovery platform that provides self-service BI for all business users and organizations. With QlikView, you can analyze data and use your data discoveries to support decision-making. QlikView is a leading business intelligence and analytics platform in Gartner Magic Quadrant. On the screen, you can see how the interface of QlikView looks like. Now talking about its features. QlikView provides interactive guided analytics with in-memory storage technology. During the process of data discovery and interpretation of collected data, the QlikView software helps the user by suggesting possible interpretations. QlikView uses a new patent in-memory architecture for data storage. All the data from the different sources is loaded in the RAM of the system and it is ready to be retrieved from there. It has the capability of efficient social and mobile data discovery. Social data discovery offers to share individual data insights within groups or out of it. A user can add annotations as an addition to someone else's insights on a particular data report. ClickView supports mobile data discovery within an HTML5-enabled touch feature which lets the user search the data and conduct data discovery interactively and explore other server-based applications. ClickView performs OLAP and ETL features to perform analytical operations, extract data from multiple sources, transform it for usage, and load it to a data warehouse. The companies that can help you start your career in ClickView are Mercedes-Benz, Capgemini, Citibank, Cognizant, and Accenture, to name a few. At number 2, we have Power BI. Power BI is a business analytics solution that lets you visualize your data and share insights across your organization or embed them in your app or website. It can connect to hundreds of data sources and bring your data to life with live dashboards and reports. Power BI is the collective name for a combination of cloud-based apps and services that help organizations collate, manage, and analyze data from a variety of sources through a user-friendly interface. Power BI is built on the foundation of Microsoft Excel and has several components such as Windows desktop application called Power BI Desktop, and online software as a service called Power BI Service, mobile Power BI apps available on Windows phones and tablets, as well as for iOS and Android devices. Here is how the Power BI interface looks like. As you can see, there is a visually interactive sales report with different charts and graphs. Moving on to the features of Power BI, it has an easy drag and drop functionality with features that make data visually appealing. You can create reports without having the knowledge of any programming language. Power BI helps users see not only what's happened in the past and what's happening in the present, but also what might happen in the future. It offers a wide range of detailed and attractive visualizations to create reports and dashboards. You can select several charts and graphs from the visualization pane. Power BI has machine learning capabilities with which it can spot patterns in data and use those patterns to make informed predictions and run what-if scenarios. Power BI supports multiple data sources such as Excel, text CSV, Oracle, SQL Server PDF, and XML files. The platform integrates with other popular business management tools like SharePoint, Office 365, and Dynamics 365, as well as other non-Microsoft products like Spark, Hadoop, Google Analytics, SAP, Salesforce, and MailChimp. Some of the companies using Power BI are Adobe, AXA, Carlsberg, Capgemini, and Nestle. Moving on to the next tool. So any guesses as to what we have at number 1? You can comment in the chat section below. Finally, on the top of the pyramid, we have Tableau. Gartner's Magic Quadrant of 2020 classified Tableau as a leader in business intelligence and data analysis. Tableau Interactive Data Visualization Software Company was founded in Jan 2003 in Mountain View, California. Tableau is a data visualization software that is used for data science and business intelligence. It can create a wide range of different visualization to interactively present the data and showcase insights. The important products of Tableau are Tableau Desktop, Tableau Public, Tableau Server, Tableau Online, and Tableau Reader. This is how the interface of Tableau Desktop looks like. Now, coming to the features of Tableau. Data analysis is very fast with Tableau, and the visualizations created are in the form of dashboards and worksheets. Tableau delivers interactive dashboards that support insights on the fly. It can translate queries to visualizations and import all ranges and sizes of data. Writing simple SQL queries can help join multiple data sets and then build reports out of it. You can create transparent filters, parameters, and highlighters. Tableau allows you to ask questions, spot trends, and identify opportunities. With the help of Tableau Online, you can connect with cloud databases, Amazon Redshift, and Google BigQuery. The companies using Tableau are Deloitte, Adobe, Cisco, LinkedIn, and the American e-commerce giant Amazon, to name a few. And there you go. Those are the top 10 data analysis tools.
R is a statistical programming language and environment that integrates statistical computing and graphics. R is powerful and stable software. Python. Python can also be called as a general-purpose programming language for data analysis and scientific computing. Python can be considered as the best player in machine learning. Python is an expressive language with many built-in functions. Both are open source software and platform independent. And they are platform neutral and also compatible with all major operating systems including Unix, Windows and Mac. Next, we will be covering different parameters. We will be covering learning preferability, mathematical fundamentals, speed of both the languages, visualization and graphics, data handling capacity, demand, community and customer support, employment possibility in both the languages. Let us cover it one by one. First one is learning preferability or ease of learning. Python is renowned for its ease of use. Python's notebooks offer excellent tools for sharing and documentation despite the fact that there are currently no GUIs for them. Programmers find R as difficult language as a beginner. This implies that the programmers must devote a significant amount of time to learn and comprehending R coding. Coming to mathematical fundamentals required. Coming to Python, understanding descriptive analysis is very important. In layman's terms, descriptive statistics often refers to the process of explaining using certain representative techniques such as charts, tables, Excel files, etc. Python statistics is a built-in library for descriptive statistics. If your data sets are not too big or if you can't rely on importing other libraries, you can use Python. On the other hand, R requires basic statistics. From basic statistics, what I mean is mean, mode and median are the terms used most frequently in basic statistics. It is referred to as measures of central tendency. Probability statistics plays an important role in handling various types of probability distribution. It includes binomial and normal distribution. Next parameter is speed. Python is an interpreted language with dynamic typing. Python always executes slowly because the code is executed line by line. Compared to MATLAB and Python, R language is significantly slower. R packages are substantially slower than those for other languages. Now that we have covered speed, coming to data visualization and data collection in Python. When selecting data analysis tools, visualization are crucial and Python has some incredible visualization tools. In Python, to large and varied scatter plots using regression lines, we can use ggplot2 and ggplot tools. Compared to raw values, visualized data is easier to comprehend. Therefore, R has many packages that offers sophisticated graphic features. In R, we can use tools like matplotlib, Seaborn, etc. Data handling capability in both Python and R. The new releases in Python have resolved the issue with the Python packages for data analysis. R is useful for analysis because of the abundance of packages, accessibility of the test, and benefit of employing formulas. However, simple data analysis can also be done using the need to install many packages. Crucial part of parameter, that is tools and libraries in Python and R. As a Python developer, one needs to be well versed in the best libraries because Python has a lot of libraries that have many different uses. Libraries like TensorFlow, Scikit-learn, NumPy plays an important role in solving many Python-related problems. Libraries perform a wide variety of tasks in R that are very beneficial for data science operations. Example for that is dplyr, bioconductor, etc. Community and customer support index offered by Python and R. Compared to R, Python has a larger community. For assistance, we can contact www.python.org. For any queries regarding Python and help, you can you can visit support.realpython.com. For any help and queries, R offers you with RStudio community. R provides assistance through its official website. For queries and community-related issues, we can contact www.r-project.org. Next is job opportunities in Python and R. A recent survey from Indeed.com predicts that at least 55,000 Python jobs in the USA with exponential pay rates are available. Big tech companies like Google, Amazon, Twitter, Facebook requires Python developer to handle massive amount of data. Position provided for a Python developer is software engineer, data analyst, data scientist, and many more. Career in R is an excellent job opportunity for you as a beginner. Big tech companies like Google, Twitter, Facebook are using R. Position provided by companies as a R developer is data scientist, data analyst, data visualization analyst, etc. Moving on, let us wrap up an important topic, which language to be used between R and Python. There is no right or wrong way to study both Python or R. Both are in demand skills that will enable you to complete almost any data analytics work you come across. It ultimately depends on your background, interest, and career objectives that which one is better for you. But compared to R, Python is easy to learn. Let's compare its strengths and weaknesses. It is used to handle large amount of data. Python performs non-statistical functions and it is best suitable for programming. However, Python is better when it comes to coding. Whereas R is used in data visualization graphics, R is a widespread language in the statistical community. It is used to accomplish many mathematical tasks. So before concluding the topic, let me answer the query that I have asked regarding R and Python. Do you guys remember the question? The query was, R language is superficially related to which language? So the answer for the question is C language.
If you categorize the steps to become a data analyst, these are the ones. Firstly, you need to focus on skills. Followed by that, you need to have a proper qualification. Then, test your skills by creating a personal project, an individual project. Followed by that, you must focus on building your own portfolio to describe your caliber to your recruiters. And then, target to the entry-level jobs or internships to get exposure to the real-world data problems. So these are the 5 important steps. Now, let's begin with the step 1, that is skills. So, skills are basically categorized into 6 steps: data cleaning, data analysis, data visualization, problem solving, soft skills, and domain knowledge. So these are the tools: Excel, MySQL, R programming language, Python programming language, some data visualization tools like Tableau, Power BI, and next comes the problem solving. So these are basically the soft skill parts. Problem solving skills, domain knowledge, the domain in which you're working, maybe a pharma domain, maybe a banking sector, maybe automobile domain, etc. And lastly, You need to be a good team player so that you can actively work along with the team and solve the problem collaboratively. Now, let's move ahead and discuss each and every one of these in a bit more detail. Starting with Microsoft Excel. While advanced tools are prevalent, proficiency in Excel remains vital for data analysts. Excel versatility in data manipulation, visualization, and modeling is unmatched. It serves as a foundational tool for initial data exploration and basic analysis. Data management. Database management skill is indispensable for data analysts. As data volumes soar, efficient management and retrieval from databases is critical. Proficiency in database systems and querying languages like SQL ensures analysts can access and manipulate data seamlessly. Followed by that, we have statistical analysis. Statistical analysis allow analysts to uncover hidden trends, patterns, and correlationships within data, facilitating evidence-based decision making. It empowers analysts to identify the significance of findings, validate hypotheses, and make reliable predictions. Next, after that, we have programming languages. Proficiency in programming languages like Python is essential for data analysts. These languages enable data manipulation, advanced statistical analysis, and machine learning implementations. Next comes data storytelling, or also known as data visualizations. Data storytelling skill is paramount for data analysts. Data storytelling bridges the gap between data analysis and actionable insights, ensuring that the value of data is fully realized in a world where data-driven communication is central to business success. Data visualization skill is a cornerstone for data analysts. As data complexity grows, the ability to present insights clearly and persuasively is paramount. Next is managing your customers and problem solving. Managing all your customers' data and companies' relationships is paramount. Strong problem solving skills are important for data analysts with complex data challenges and evolving analytical methodologies. Analysts must excel in identifying issues, formulating hypotheses, and devising innovative solutions. In addition to the technical skills, data analysts in 2025 will require strong soft skills to excel in their roles. Here are the top ones. Data analysts must effectively communicate their findings to both technical and non-technical stakeholders. This includes presenting complex data in a clear and understandable manner. Next soft skill is teamwork and collaboration. Data analysts often work with multidisciplinary teams alongside data scientists, data engineers, business professionals. Collaborative skills are essential for sharing insights, brainstorming solutions, and working cohesively towards common goals. And last but not least, domain knowledge. Knowledge on domain in which you're currently working is really important. It might be a pharmaceutical domain, it can be an automobile domain, it can be banking sector, and much more. Unless you have a basic foundational domain knowledge, you cannot continue in that domain with accurate results. Now, the next step, which was about the qualification to become a data analyst. Master's courses, online courses, and boot camps provide strong, structured learning that helps you gain in-depth knowledge and specialized skills in data analysis. Master's programs offer comprehensive, academically rigorous training and often include research projects, making sure you're highly competitive in the job market. Online courses allow flexibility to learn at your own pace while covering essential topics, and boot camps offer immersive, hands-on training in a short period focusing on practical skills. All three paths enhance your credibility, keeping you updated on industry trends and make you more attractive to potential employers. If you are looking for a well-curated all-rounder, then we have got you covered. Simplilearn offers a wide range of courses on data science and data analytics, starting from master's, professional certifications, to post-graduations and boot camps from globally reputed and recognized universities. For more details, check out the links in the description box below and comment section. Now, proceeding ahead, we have the projects for data analyst. Data analyst projects demonstrate practical skills in data cleaning, visualization, and analysis. They help build a portfolio showcasing your expertise and problem-solving abilities. Projects provide hands-on experience bridging the gap between theory and real-world application. They show domain knowledge, making you more appealing to employees in specific industries. Projects enhance your confidence and prepare you to discuss real-world challenges in interviews. Proceeding ahead, the next step is about the portfolio for data analysts. A portfolio is a testament that demonstrates your skill and expertise through real-world projects. showcasing your ability to analyze and interpret data effectively. It provides tangible proof of your capabilities, making you stand out to the employers. Additionally, it highlights your domain knowledge and problem solving skills, giving you a competitive edge during job applications and interviews. Last but not the least, data analyst internships. Internships provide hands on experience with real world datasets, tools, and workflows, bridging the gap between theory knowledge and practical application. They offer exposure to industry practices, helping you understand how data is used to drive decisions. Internships also build your professional network, enhance your resume, and improve chances of securing a full-time data analyst role.
What's in it for you? Now we're going to go over what is NumPy, installing and importing NumPy, NumPy array versus Python list, basics of NumPy, finding size and shape of any array, range and arrange functions, NumPy string functions. And then in part 2, I'll move on to cover axes, array manipulation, and much more. So let's start with what is NumPy. NumPy is the core library for scientific and numerical computing in Python. It provides high-performance, multi-dimensional array object and tools for working with arrays. And I'll go a step further and say there are so many other modules in Python built on NumPy. So the fundamentals of NumPy are so important to latch onto for the Python so that you can understand the other modules and what they're doing. NumPy's main object is a multi-dimensional array. It is a table of elements, usually numbers, all of the same type, indexed by a tuple of position integers. In NumPy, dimensions are called axes. Take a one-dimensional array, or we have, and remember dimensions are also called axes, so you can say this is the first axis, 0, 1, 2, 3, 4, 5. And you can see down here it has a shape of 6. Why? Because there's 6 different elements in it in the one-dimension array. And they usually denote that as 6 comma with an empty node on there. And then we have a two-dimensional array where you can see 0, 1, 2, 3, 4, 5, 6, 7. And in here we have 2 axes or 2 dimensions, and the shape is 2, 4. So if you were looking at this as a matrix or in other mathematical functions, you can see there's all kinds of importance on shape. We're not going to cover shape today, but we will cover that in part 2. Did you know that NumPy's array class is called ND array for NumPy data array? Now we're going to take a detour here because we're working in Python, and 2 of my favorite tools in Python is the Jupyter Notebook, and then I like to use that sitting on top of Anaconda. And if you flip over to jupyter.org, that's jupyter.org, you can go in here. You can install it off of here if you don't want to use the Anaconda notebook, but this is the Jupyter setup, the documentation on the Jupyter. Jupyter opens up in your web browser. That's what makes it so nice, is it's portable. The files are saved on your computer. They do run in IPython or IronPython, and you can create all kinds of different environments in there, which I'll show you in just a minute. I myself like to use Anaconda. That's www.anaconda.com. If you install Anaconda, it will install the Jupyter Notebook with the Anaconda separate. And you can install Jupyter Notebook and it'll run completely separate from Anaconda's Jupyter Notebook. And you can see here I've now opened up my Anaconda Navigator. What I like about the Navigator, and this is a fresh install on a new computer, which is always nice, I can launch my Jupyter Notebook from in here. I can bring other tools, so the Anaconda does a lot more. And under environments, I only have the one environment, and I can open up the terminal specific to this environment. This one happens to have Python 3.7 in it, the most current version as of this tutorial. And then you open a terminal if you're going to do your pip installs and stuff like that for different modules. You can also create different environments in here. So maybe you need a Python 3.6, Python 3.5. You can see we're having a nice framework like Anaconda really helps. So you don't have to track that on your own in the Jupyter Notebook and your different Jupyter Notebook setups. We'll go ahead and launch this Jupyter Notebook. And then I've set my browser window for a default of Chrome. So it's going to open up in Chrome. And you can see here, this opens up a folder on my computer. We have a couple different options on here. Remember, I set the environment up as Python 3.7. You would install any additional modules that aren't already installed in your Python on this. And it keeps them separate, so you do have to, for each environment, install the separate modules so they match the environment on there. And in here we have a couple things where you can look up what's running. You have your different clusters. Again, I just installed this on a new machine, so I just have a couple things in here that were run on here recently. And where we go on here is we then have on the upper right, New, and from the pull down menu you'll see Python 3. And this will open up a new window. And now we're in Jupyter Python. So this is a Python window. We'll just do a print. And this, of course, is, let's go hello world. And we'll run that, and it prints out hello world in the command line. There's a couple special things you have to know what we're not going to do today, which is on graphics. If you've never seen this, one of the things you can do is you can also do A equals hello world. And if you just put the A in there, now if you do a bunch of these where you have A equals hello world, B equals goodbye world, and you put A, B, A, then return B, it'll only run the last one. But you can see here, if you put the variable down here, it will show you what's in that variable. And that has to do with the Jupyter Notebook inline coding. So that's not basic Python, that's just Jupyter Notebook shorthand, which you'll see in a little bit. So back to our NumPy array versus Python list. Python list being the basic list in your Python. Why should we use NumPy array when we have Python list? Well, first, it's fast. The NumPy array has been optimized over years and years by multiple programmers, and it's usually very quick compared to the basic Python list setup. It's convenient, so it has a lot of functionality in there that's not in the basic Python list. And it also uses less memory, so it's optimized both for speed and memory use. And let's go ahead and jump into our Jupyter Notebook. Since we're coding, best way to learn coding is to code. Just like the best way to learn how to write is write, and the best way to learn how to cook is cook. So let's do some coding here today.
But before we move on, let's understand first what is Jupyter Notebook. So guys, as you can see all over here, that Jupyter Notebook is a popular open source tool that basically allows you to create and share documents which contains codes, equations, you can have visualizations also. Basically, it is used for data analysis, machine learning, and scientific research, which makes it a very essential tool for developers like data scientists and researchers alike. Now, before installing Jupyter Notebook, I request you that you have Python installed in your system. So the requirement should be Python 3.6 or greater. So now let us officially navigate to the Python's website. So guys, as you can see all over here, so on python.org, if I click on download Python, so we're going to see that all over here, download Python 3.125. So as I already told you that the requirement of Python should be greater than 3.6. So just you can click all over here and you can see the download had started. So guys, as you can see all over here that we have installed the Python. Now let us open the file. So you can see the given software is going to install on this directory. Okay. So just click all over here. So guys, as you can see all over here, the Python installation of 3.125 is in progress. Let's wait for some time till it gets installed. So as you can see guys all over here that we have successfully installed our Python. Now let us open our terminal and let us check whether Python is correctly installed. So we are going to type python/version. So as you can see all over here, we have successfully installed our Python. So guys, that was our prerequisite. Now, there are two ways to install Jupyter Notebook. The first one can be pip. Okay, pip is a package manager, or using Anaconda distribution. So let us see with pip first. So guys, pip is a package manager which is used to install and manage software packages, libraries written in Python. So you can see all over here that the Python with version greater than 3.6 have default pip installed in them. Okay, so we can use pip command to install our Jupyter Notebook. So guys, as you can see all over here, we have come to the official documentation of jupyter.org, and it is saying that installing Jupyter Lab with pip command. So what you can do guys, you can just copy all over here. You can go right all over here and click on this. Now, as you can see all over here, it has started downloading the Jupyter Lab. So guys, we are going to install our Jupyter Lab with the pip command. So this is the official documentation of Jupyter Notebook. Okay, and just all you have to do is copy this and type on your terminal. So as you can see all over here, it has started downloading the packages which is required to download the Jupyter Notebook. Let us wait for some time. Okay guys, so we have successfully completed this step. Now let us move on to our next step. So as you can see all over here, so we have installed, okay. Then what we have to do, then you can type this, you can launch the Jupyter Lab with this command on the terminal. Now let us wait. So as you can see all over here guys, we have successfully installed our Jupyter notebook. So you can go all over here and just create a new notebook, and you can also choose your kernel and you can start working on your Jupyter notebook. Suppose I'll show you one snippet. So 3 plus 5, let us try to run this notebook. So as you can see, it is giving us the 8 as answer. So it is following the Python syntax, and in this way we have successfully installed our Jupyter notebook using the pip command. So now, as you can also see all over here, you can also install Jupyter notebook with this command, pip install notebook, and then you can just open it. This is also another alternative. Similarly, you can install with Viola also. Same command and just open the Viola. Now, if you are using any other operating system like macOS or Linux, then you can install by brew install Jupyter Lab. So Homebrew will be the package manager for macOS and Linux. So I hope so you are pretty clear with how to install Jupyter Notebook with the pip command. Now, I have downloaded Anacondas from this official website. So as you can see all over here, this is the official website of Anaconda. Okay. Now just type your email and you can just download it. So similarly, as you can see, after installing, I'm going to launch my installer and let us click next. Okay. Let us click agree. Okay. And let us install this on the given directory. Let us wait for some time till the installation gets complete. So guys, as you can see all over here, we have completed our installation of Anaconda. So just click on finish and you can say we have successfully installed our Anaconda. Now let us open our Anaconda navigator. So just click on So as you can see all over here, just right click on this and our Anaconda navigator will be opened. So as you can see all over here, this is our Anaconda navigator and it is loading the packages. And for us to install the Jupyter notebook, so as you can see all over here, just click on launch. So guys, if you click on launch, it is going to open our Jupyter notebook. So as you can see all over here, it is saying launching the Jupyter notebook and it is hosted on localhost 8889. So this is our hosted Jupyter notebook. And similarly, you can create a new notebook all over here. And in this way, you can start working.
And just like any modules, we have to import NumPy. We almost always import it as NP. That is such a standard. So you'll see that very commonly. We can just run that. And now we have access to our NumPy module inside our Python. And then the most common thing, of course, is to go ahead and create a NumPy array. And in here, we can send it a regular list. And so we'll go ahead and send this a regular array. Let's go 1, 2, 3 to make it simple. And then I'm just going to type in A, and we'll run this. And so you can see down here, the output is an array of 1, 2, 3. And we could also do print, just a reminder that this is an inline command, so that wouldn't work if you're using a different editor. You can see that it's an array 1, 2, 3. But we'll go ahead and leave it as A. Kind of a nice feature so you can see what you're doing really quick in the Jupyter notebook. And just like all your other standard arrays, I can go A of 0, which is going to be a value of 1. Of course, we do A of 1. You go all the way through this. A of 1 has a value of 2 in it. So whether you're using the NumPy array or the basic Python list, that's going to be the same. That should all look pretty familiar and be pretty straightforward. Remember, the first value is always 0. And when we set on there. So let's take a look why we're using NumPy, because we went over the slide a little bit, but let's just take a look and see what that actually looks like. And what we want to look at is the fact that it's fast, convenient, and uses less memory. So let's take a glance at that in code and see what that actually looks like when we're writing it in Python and what the differences are. And to do this, I'm going to go ahead and import a couple other modules. We're going to import the time module so we can time it. And we're going to import the system module so that we can take a look at how much memory it uses. And we'll go ahead and just run those so those are imported. And so we'll do b equals range of 1. Yeah, 1000 is fine. And so that's going to create a list of 1,000, 0 to 999. Remember, it starts at 0 and it stops right at the 1,000 without actually going to the 1,000. And let's go ahead and print. And we want system.getSize of. And we'll pick any integer because we have, 0 to 1,000. We'll just throw one in there, 5. It doesn't matter because it's going to, whatever integer we put in there is going to generate the same value because we're looking at the size of how much memory it stores an integer in. And then we want to have the length of the b. That's how many integers are in there. And if we go ahead and execute this and run this at a line, we'll see, oops, I did that wrong, comma. If we multiply them together, we'll see it generates 28,000. So that's the size we're looking at, is 28,000. I believe that's bytes. That sounds about right. So let's go ahead and create this in NumPy. And we'll go C equals NP. And this is a range. So that's the NumPy command to do the same thing that we were just doing in a list. And we'll also use the same value on there, the 1,000. And then once we've created the value of C for np.arange, let's go ahead and print. And we can do that by doing c.size times c.itemSize. And that's very similar to what we did before. We did get the size of, so the C size is the size of the array, and each item size, just reversed. So it's the size of an integer 5, item size is going to be the integers, and C size. And let's just take a look and see what that generates. And wow, okay, we got 4,000 versus 28,000. That's a significant difference in memory, how much memory we're using with the array. And then let's go ahead and take a look at speed. Let's do size. We tried this with lower values, and it would happen so fast that the NP array kept coming up with 0 because it just rounded it off. So size, and let's create an L1 equals range of size, and we'll do an L2. We'll just set up to the same thing. It's also range of size on there. There we go. And then we can do on A1 equals np dot arange size. And then let's do on A2 equals np dot arange. We'll keep it the same size. And what we're going to do is we're going to take these two different arrays and we're going to perform some basic functions on them. But let's go ahead, actually let's just load these up now. We'll go ahead and run this so those are all set in memory. Except for the typo here. Quickly fix that. There we go. So these are now all loaded in here. And let's do a start equals time.time. So it's just going to look at my clock time and see what time it is. And then we'll do result equals, and let's do, let's say we got an array, and we're going to say, let's do some addition here. X plus Y for X comma Y. And we'll zip it up here. Two different arrays. So here's our two different arrays. We're going to multiply each of the individual things on here. L1, L2. There we go. So that should add up each value. So L1 plus L2, each value in each array. And then we want to go ahead and print. And let's say Python list took. And then we'll do time dot time. We'll just subtract the start out of there. So time, whoops, I messed up on some of the quotation marks on there. Okay, there we go. Time minus the start. And we'll convert that to seconds. So we'll go, because that's in milliseconds, so times 1,000. And let's hit the run on there. This is kind of fun because you also get a view while we're doing this of some ways to manipulate the script. And as you can see also my bad typing. There we go. Okay, so we'll go ahead and run this. And we can see here that the Python list took 34. Actually, I have to go back and look at the conversion on there. But you can see it takes roughly 0.34 of a second. And we can go ahead and print the result in here too. Let's do that. We'll run that just so you can see what kind of data we're looking at. And we have the 0, 2, 4, 6, 8. So it's just adding them together. It looks pretty straightforward on there. And if we scroll down to the bottom of the answer, again, we see Python list took 46. A little different time on there depending on what core, because this is on an 8-core computer, so it just depends on what core it's running on, what else is pulling on the computer at the time. And let's go back up here and do our start time. Paste that into here. And this time we're going to do a result equals, and this is really cool. Notice how elegant this is. It's so straightforward. This is a lot of reason people started using NumPy is because I can add the two arrays together by simply going A1 plus A2. It makes a lot of sense, both looking at it, and it's just very convenient. Remember that slide we're looking at? Fast, convenient, and less memory. So look how convenient that is. Real easy to read, real easy to see. And I don't know if we don't need to print the result again, so let's just go ahead and print the time on here. And we'll borrow this from the top part because I really am a lazy typer. And this isn't the Python list, this is the NumPy list, or NumPy array. And let's go ahead and see how that comes out. And we get 2.99. So let's take a look at these two numbers, 46 versus 2.99. So we'll just round this up to 3. That's a huge difference. That's like more than 10 times faster. That's like 15 times roughly at a quick glance. I'd have to go do the math to look at it. And it's going to vary a little bit depending on what's running in the background on the computer, obviously. So we've looked at this, and if we go back here, we found out it's much faster. Yes, there's going to be different speeds depending on what you're doing with the array. Very convenient, easy to read, and it uses less memory. So that's the core of the NumPy. That's why a lot of people base so many other modules on NumPy and why it's so widely used. So we did glance at a couple operations while we were looking at speed and size. Let's dive into a little bit more into the basic operations. And these are always nice to see. I mean, certainly you want to go get a cheat sheet if you're using it for the first time. Look things up. Google is your friend. We did this for the most basic numpy.array or np.array. And we'll go ahead and create an array. Let's do pairs, 1, 2. And then let's do 3, 4. And if we're going to do that, let's do 5, 6. There we go. And if we go ahead and take this and run this, I can go ahead and do our A down here so it's in line and it'll print that out. You can see it makes a nice array for us. So we have A, and if you look at that, we have 3 different objects, each with 2 values in them. And hopefully you're starting to think, well, how many dimensions or indexes is that? And you'll see 3 by 2. So let's go ahead and take a look, and let's go, how about A.nDimensions? Speaking of which, we'll run that, and we have 2 dimensions for each object. And then we can do the item size, so A dot. We saw this earlier, where we looked up how many items. It was up here, where we wanted to multiply item size times the actual size of the object. So the memory is being used versus the item size. And we should see 4 there. Memory is compressed down. That's always a good thing. And then the shape. The shape is so important when you're working with data science and you're moving it from one format to another. So we have our shape. We just talked about that. We have 3 by 2. 3 rows by 2 objects in each one. Generally, I don't look too much at the size, but the dimensions I'm always looking up. And this is nice, you can automate it. So you might be converting something, you might need to know how many dimensions are going into the next machine learning package so that you can automatically just have it send that information over. So we looked at A shape. Let's go ahead and create a slightly different array, np.array. Let's go ahead and just do as our original setup here. And one of the features we can do, which is really important, is we can do dtype equals, in this case, let's do np float 64. And so what we've done is we're converting all of these into a float, and we type in A. And now instead of having 1, 2, 3, 4, 5, 6, you see they're all float values. 1.0, there's no actual 0 in there, just there's a 1 dot, or the 1 period, 2, 3 period, 4 period, 5 period, 6 period. And this, again, data science, I don't know how many times I've had to convert something from an integer to a float so that's going to work correctly in the model I'm using. So very common features to be aware of and to be able to get around and use. And we'll also do, let's just curiosity, item size. We'll go ahead and run that. And we see that it doubled in size. So it's not a huge increase. Well, doubling is always a big increase in computers. But it's not a huge increase compared to what it would be if you're running this in the Python list format. And then we did the shape earlier without having it set to the float 64. Let's go ahead and do a shape with it set to 64. And it should be the same 3, 2, so it all matches. So we've gone through, and remember, if this is all brand new to you, according to the Cambridge study at the Cambridge University, if you're learning a brand new word in a foreign language, the average person has to repeat it 163 times before it's memorized. So a lot of this, you build off of it, so hopefully you don't have to repeat it 163 times. But we did manage to repeat it at least twice here, if not a little bit more. And let's go ahead and take this. We're going to go look at one more setup on here. And let me just take this last statement here on the converting our properties of our data. And instead of float 64, let's do complex. Let's just see what that looks like. And let's go ahead and print that out and run it. And so we now have a complex data set up, and you'll see it's denoted by the 1 dot plus 0 dot j. And if we flip over here and do a basic search for NumPy data types, better to go to the original web page, but pull up a bunch of these. You can see there's a whole list of different NumPy data types. Shorthand, complex, we have complex, complex 64, complex 128. Complex number represented by 2 64-bit floats, real and imaginary components. One option on there, float 16, float 32. Float, shorthand for float 64, most commonly used. And of course all the different ones that you can possibly put into your NumPy array. So we covered a basic addition up there when we were comparing how fast it runs. But some very basic components, how to set up a NumPy array, how many dimensions it has, item size, data type, again we went to item size, and there's also the shape. Probably one of the more used. I use a shape all the time, very commonly used. And then down here you can see where we actually created a NumPy complex data type. So let's look at some other features in NumPy. One of them is you could do NumPy dot zeros, and we're going to do 3, 4. There we go. And we'll go ahead and run this, and you can see if I do np.zeros, I create a NumPy array of zeros. This is really important. I was building my own neural network, and I needed to create an array where I initialized the weights, and I wanted them all to be the same weight. In this case, I wanted them to start off as 0 for the particular project I was working on. And there's other options, like you can do NumPy1s, and we'll do the same thing, 3, 4, we'll run that. And you can see I've created an array of NumPy1s. In this case, it comes out as a float array. And then this is an interesting to note, because we have, let's go back to our Python and do L range 5, and we'll print the L, so there's our list. And if I run that, it doesn't create the range until after the fact, until you actually execute it. That's an upgrade in Python. Python 2.7 actually created the array, 0, 1, 2, 3, 4. This one actually creates the script, and then once it's used, it then actually generates the array. And if we do that in NumPy A range, remember that from before, and if we do NumPy A range 5, and let's do L equals, or we can just leave it as NumPy, that's fine. There we go, just run that. You can see there we actually get an array, 0, 1, 2, 3, 4 for the value of the NumPy A range 5. It generates the actual array. And for part 1, we're going to do just one more section on basic setup. And we're going to concatenation, do a concatenation out example. There we go. We're going to do strings. Let's take a look at strings and what's going on with there. And let's do, let's see, print. Let's do an NP character, something new here. And we're going to add, and then here's our brackets for what we're going to add. And let's say, let's do hello, comma, hi. And in the brackets on there, let's create another one. and this one's going to be ABC, and we'll do XYZ. So we're just creating some, randomly making some up on here. And then we'll go ahead and just print this. If we run that, you can come down here, and of course make sure all your brackets are open and closed correctly. And then you can see in here when we concatenate the example in NumPy, it takes the two different arrays that we set up in there, and it combines the hello with the ABC and the hi with XYZ. And if we can also do something like print, let's do np character dot multiply. So there's a lot of different functions in here. Again, you can look these up. It's probably good to look them all up and see what they are, but it's good to also just see them in action. And let's do hello space, comma, 3, and we'll run this one and run that without the error. And you'll see it does hello, hello, hello. So we multiplied it by 3. And we can also, and let's just take this whole thing here instead of retyping it. And we can do character center. So instead of multiply, let's do center. And over here, keep our hello going. Take the space out of there. And let's do center at 20. And fill character equals, we'll fill it with dashes. So if we run this, you can see it prints out the hello with dashes on each side. And we keep going with that. We can also, in addition to doing the fill function, we can play with capitalize, we can title, we can do lowercase, we can do uppercase, we can split line, strip, join. These are all the most common ones. And let's go ahead and just look at those and see what those look like, each one of them. Here we're going to do the hello world, all-time favorite of mine. I always like to say hello universe. And you can see here we did a capital H with the world, but so we want to capitalize. So capitalize is the first one in the array. So we get hello world on there. And we can also take this, and instead of capitalizing, another feature in here is title. And let's just change this to how are we doing? How are you doing? Instead of we, we'll do you. And let's run that. And you can see here, because we created it as a title, it capitalizes the first letter in each word. And in this one, we're going to do character lower. Two different examples here. We have an array. We have hello world all capitalized, and we have just hello. And you can see that one is an array and one is just a string. If we run that, you get an array with hello world lowercase and hello lowercase. And if we're going to do it that way, we can also do it the opposite way. There's also upper. And let's paste those in there. And you can see here we have character.upper opposite there, python.data, and we'll do Python is easy. Hopefully you're starting to get the picture that most of the Python and the scripting is very simple. It's when you put the bigger picture together and starts building these puzzles, and somebody asks you, hey, I need the first letter capitalized, unless it's the title, and then you start realizing that this can get really complicated. So NumPy just makes it simple, and we like that. And so in this case, we did Python data. It's all uppercase. Python is easy, like shouting in your messenger. Python is easy. And then if you're ever processing text and tokenizing it, a lot of times the first thing you do is we just split the text, and we're just going to run this np.character.split. Are you coming to the party? If we do that, it returns an array of each of the individual words. Are you coming to the party, splitting it by the spaces? And then if you're going to split it by spaces, we also need to know how to split it by lines. And just like we have the basic split command, we also have split lines. Hello, and you'll see here the scoop in for our new line. And when we run that, if you're following the split part with the words, you should see hello, how are you doing? The two different lines are now split apart. And let's just review 3 more before we wrap this up. Commonly used string variable manipulations. We have strip, and in this case we have Nina, admin, Anita, and we're going to strip A off of there. And let's see what that looks like. And then you end up with nin, demin, nate. It basically takes up all leading and trailing letters. In this case we're looking for A. More common would be a space in there, but it might also be punctuation or anything like that that you need to remove from your letters and words. And if we're going to strip and clean data, we also need to be able to reformat it or join it together. So you see here we have a character join. We'll go ahead and run this. And it has on the first one, it splits each of the letters up by the colon and the second one by the dash. And you can see how this is really useful if you're processing, in this case, a date. We have day, month, year, year, month, date. Very common things to have to always switch around and manipulate depending on what they're going into and what you're working with. And finally, let's look at one last character string. We're going to do replace. If you're doing misinformation, this is good, pulling news articles and replacing is and what. In this case, we're just doing he is a good dancer. We're going to replace is with was. And you can see here, he was a good dancer. Hopefully that's not because he had a bad fall. He just was from 1920s and has gotten old. So there we go. We've covered a lot of the basics in NumPy as far as creating an array. Very important stuff here when you're feeding it in. How do we know the shape of it, the size of it? What happens when we convert it from a regular integer into a float value as far as how much space it takes? We saw that doubled it. Item size, you have your in dimensions, and probably the most used is shape. And we'll cover more on shape in part 2. So make sure you join us on part 2 because there's a lot of important things on shape in there and the setting them up. We also saw that you can create a zeros based array. You can create one with ones. If we do a range, you can see how it is a lot easier to use to create its own range, or a range as it is in NumPy. And you saw how easy it was to add two arrays. We saw that earlier, just plus sign. Then we got into doing strings and working with strings and how to concatenate. So if you have two different arrays of strings, you can bring them together. We also saw how you can fill, so you can add a nice headline, dash, dash, dash. We saw about capitalize the first letter. We saw about turning it into a title, so all the first letters are capitalized. Doing lowercase on all the letters, upper for all the letters, just lower and upper, nice abbreviation. We also covered how to split the character set, how to strip it. So if you want to strip all the A's out from leading A's and ending A's or spaces, you can do that very easily. Also how to join the data sets. So here's a character join option for your strings. And finally we did the character replace. Now let's go ahead and dive in there since we're going right into part 2, which is getting some coding going under our belt. And here in our Jupyter notebook, we can go under New and create a new folder, Python 3. I think I forgot to do this last time, but we could just do the Control++, which in any browser enlarges a page, makes it a lot easier to see. Always a nice feature. Another beautiful benefit of using Jupyter Notebook. And let me go ahead and show you a neat thing we can do in Jupyter. This is nice if you're working with people and you're doing this as a demo on a large screen. I'm going to do the hashtag or pound symbol array manipulation, kind of a title of what we're working on. And then I'm going to call this cell type markdown as opposed to code. And you'll see it highlights it here, and then if I run it, it just turns it into array manipulation. And then we're specifically going to be working on array manipulation, changing shape to start with. And we'll go ahead and mark this cell also of markdown, so it has a nice little look there. And then it comes up, and you can see it, just like I said, it just highlights it and makes it in bold print, just making it easier to read. Not a Python thing, but a Jupyter thing that's good to know about, especially if you're working with the shareholders, since they're investing money in you. Of course, the first thing we want to do is import. We're going to import NumPy as in P, and that should be standard by now. By now, you start a Python program, you're doing some data science. NumPy is just something you bring in there. And let's go ahead and create our array, and we're going to do that as the np.arange. Remember, that's 0, what we're going to do 0 to 9, and then we'll go print, put a little title on the original array. We'll just print that array A. Remember from the first lesson, so we have our array which is 0, 1, 2, 3, 4, 5, 6, 7, 8. And let's add a print space in between. Let's create a second array, B, but we want this to reshape array A. And what does that mean? And the command is simply reshape, and then we have 9 items in here, and this is so important right now. So be very aware, if I did some weird numbers in here, it's not going to work. And we want multiples of 9. We know that 3 times 3 is 9. So we're going to reshape our A array by 3 by 3. And then we're going to print, well, let's give it a title. Oops, I had too many brackets in there. Modified array, and then let's go ahead and print our B. And let's see what that looks like. And as we come down here, you can see we've taken this and it's gone from 0, 1, 2, 3, 4, 5, 6, 7, 8 to an array of arrays. And we have 0, 1, 2, 3, 4, 5, 6, 7, 8. And so we split this into 3 by 3. And you can guess that if I tried to reshape this, let's just do a 5 by 3, which is 15, that's going to give me an error. So it's not going to work. You're not going to be able to reshape something unless the shape, all the data in there matches correctly. So we can take this flat 9, and we call it a flat because it's just a single array. And we can reshape it into a 3 by 3 array. And first you might think matrices, which this is used for that, definitely. I use it a lot in graphing because they'll come in that I have an array that's xy, comma xy1, y1, comma x2, y2. And so the shape of it might be 2 by the length of the number of points. And I need to separate that into x flat array and a y flat array. And you can see this can be very easy to reshape the array doing that. And we can of course go back. We can do b, do a print, and we'll do b dot flatten. Remember I said it's called a flatten array? And if we run that, you'll see it just goes back to the original one. It takes this 0, 1, 2, 3, 4, 5, 6, 7, 8 and flattens it back to a single array. And then one other feature to be aware of is if we flatten it, one of the commands we can put in there is order. Let me just go ahead and do that. Order equals F. Strangely enough, F stands for Fortran. The whole Fortran days. I remember actually studying Fortran programming language. In this case, you'll see that it uses the first, like 036 is the order. So instead of flattening it like we had before, 0, 1, 2, 3, 4, 5, 6, 7, 8, it now does 0, 3, 6, 1, 4, 7, 2, 5, 8. And if you go to the NumPy array page, you can see here that they have the flatten. I just open up the NumPy ND array flatten setup to look it up. And they have 3 different options. They have C, F, and A. And it's whether to flatten in C, which was based on how the C code works for flattening, originally worked, which is row major. Fortran, which is column major, or preserve the column Fortran ordering from A. So whatever it was in, the default is the C version. So the default that you saw, you could put order equals C and it'd have the same effect as we saw there before. You could even do order equals A. That would also have the same effect because that's the default. So really the only other thing you really should change on here is to change it to C if you need it. And you can see right here, or F, I mean not C. The only thing you really want to change it to is to your F for the Fortran order, which then does it by column versus by row. And let's look at, here we go, reshape. So let's create a range of 12, and let's reshape it. And we'll do 4, 3 for this one. And remember this is NumPy. I forgot the NP there. np.arrange. And we can type in just A for print, or you can do full print A. And of course in Jupyter Notebook you even have a little extra print at the beginning. If we run this, we'll see we create a nice array of 0, 1, 2. It's reshaped it. So we have 4 rows and 3 columns, or you could call that 3 columns and 4 rows. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But this one is so important. We'll do np transpose A. Let's go ahead and run that. And it helps if I get all the S's in there and don't leave an S out. And you'll see here we've taken our array. If you remember correctly, we had 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we've swapped it. So we've gone from a 3 by 4 or a 4 by 3 to a 3 by 4. And this really helps if you're looking at like a huge number of rows and the data all comes in. Like let's say this is your features in row 1, your features in row 2, and this is X, Y, Z. Well, when you go to plot it, you send it all of X in one array, all of Y in one array, and all of Z in another array. And so it's really important that we can transpose this rather quickly. This is kind of a fun thing. I can highlight it and do brackets around it. And if you remember correctly, because we're in Jupyter, it doesn't matter where we do the print or not. It'll automatically print it for us. And you see if I hit the run button, it comes up at the same exact thing. And let's play with the reshape. And you know what, let's zoom this up a little bit here. Make that even bigger so you can really see what's going on. And let's play with the reshape just a little bit more. We'll do b equals np.arange. Let's do 8. And reshape. We'll do 2, 4. Let's go ahead and print b. And then run that. And you'll see we have now the 2 rows. This is a bit more like, so we have 4 maybe 2 rows of 4 things, or this might be all of our X components and our Y components. So we can switch it back and forth real easy. Important to note here, whether we do 2, 4, or in the case of 4, 3, this has 12 elements. And so however you split it up, it's got to equal 12. So 4 times 3 equals 12. That's pretty straightforward. Same thing down here. 2 times 4 equals 8. If I change this, and let's say I do 2, 3, let's just run that in, and you'll find we get an error because you can't split 8 up into 2 rows by 3. You have to pick something that it can split up and arrange it in. So let's go ahead and run that. And just for fun, let's go reshape our B again, if I can type. Reshape our B again. And what else goes into 8? Well, we could do 2 by 2 by 2. So we can take this out to 3 different dimensions. And then, of course, if we, because this is going to come out as a variable, we can just go ahead and run it. And it'll print it. We could also do a print statement on there, just like we did before. And you'll see we have 2 different groups of 2 variables of 2 different dimensions. So 2 by 2 by 2. And let's go ahead and assign this to a variable. C equals B reshape. And let's do something a little different. Let's roll the axes. Roll axes. And we'll take our C and do 2, 1. And if we go ahead and run this, it's going to print that out. Whoops. Hit a wrong button there. Let's do that one again. And you roll the axis, and you can see that we now have, instead of 0, 1, 2, 3, 4, 5, 6, 7, we now have the 0, 2, 1, 3, 4, 6, 5, 7. So what's going on here? We're taking and we're rolling the numbers around, and let's just simplify this. We'll just do it with C, 1 and run that. And so if we roll a single axis, you got 0, 1, and then it rolled the 4, 5 up, and then we have 2, 3, 6, 7. And if we do 2, let me see what happens there. And this is one of those things you really have to play with and start feeling what it's doing. We've now taken 0, 2, 4, 6, 1, 3, 5, 7. So you can see we've now rolled by 2 digits. Instead of rolling the 1 setup, we now rolled 2 digits up there. And so if we go back and we do the 1, so we've rolled it up, 0, 1, 4, 5. And then we're going to take the 2 in there. And we've rolled the 0, 1, 2, 3, 4, 5, and 6, 7. So we start rolling these things around on here. There's a lot of different things you can do on this. But it's another way to manipulate the numbers on your NumPy. And finally, let's go ahead and swap axes. We'll do C. And let's just go ahead and run that. It's going to give me an error on there. That's because it requires multiple arguments. Left out the arguments. So now we can swap them. We get the 0, 2, 1, 3, 4, 6, 5, 7. So you can see everything's been swapped around. So next thing we want to go over is we want to go over NumPy arithmetic operations. How can we take these and use these? Let me just go ahead and put this cell as a markdown. There we go. We'll run that so it has a nice thing. All right, nice title on there. That's always helpful. And let's start by creating 2 arrays. We'll do A is an NP range, A range 9. And let's reshape this 3 by 3. So by now you should be seeing this reshape stuff, and this should all look pretty familiar. We have our 0, 1, 2, 3, 4, 5, 6, 7, 8 on there. And let's create a second one, B. And this time, instead of doing A range, let's do NP array. We'll just create a straight up array. And we'll do an array of 3 objects. So it's going to be 3 by 1. And if we go ahead and print B out, let me run that. This is actually pretty common to have something like this, where you have a 3 by whatever it is and a 3 by 3 array. When you're doing your math, you kind of have that kind of setup on there. And what we can do is we can go np.add AB. Don't forget, we can always put a print statement on there. So if we add it, you'll see that it just comes in there and it goes, okay, we're adding 10 to everything. And we could actually do something more, make it more interesting. 10, 11, 12. So let's change B's, now 10, 11, 12, and let's run that. And you can see that we have 10, and then you had 1, plus 11 is 12, 2 plus 12 is 14, 13, so 10 plus 3 is 13, 11 plus 4 is 15, and 12 plus 5 is 17, and so on. We'll put this back since that's how the original setup was. Let's do 10 by 10 by 10 and run that and get the original answer. And if you're going to add them together, we need to go ahead and subtract A, B. And when we run that, we get minus 10, minus 9, minus 8, just like you would expect. So we have our subtraction. 0 minus 10 is minus 10, and so on. And if you're going to add and subtract, you can guess what the next one is. We're going to multiply. And we'll multiply AB. And this should be pretty straightforward. You should expect this. If we multiply 10 times 0, we got 0. 10 times 10 is 10, and so on. And finally, if you're going to multiply, what's the last one we got is divide. What happens when we do divide A by B? And we run this, and we're going to get 0. And this is 0 divided by 10 is 0, 1 divided by 10 is 0.1, 2 divided by 10 is 0.2, and so on and so on. So the math is pretty straightforward. It just makes it very easy to do the whole setup. And again, if we went this, and let's say, let's change this up here. Instead of 10, we do 100. And make this 1,000. There we go. And if we run that, and then we do the add, you can see we got 10 plus 100 plus 1,000. Same thing with the subtract. Same thing with the multiply. And then you can also see the same thing here with the divide. So a lot of control there with your array and your math. Again, let's set this back to 10. Oops, it's right up here, wrong section. There we go, 10. And we'll just go ahead and run these and get back to where we were. And this brings us to our next section, which is slicing. And let's put in our, we'll just make this a cell type markdown. And then we run that. Of course, it gives us a nice looking slicing there. And the slicing means we're just going to take sections of the array. So let's create an array NP A range. Let's just do 20. And if you remember, if we do A, we have a 0 to 19. And then we can do A, and remember we can always print these. This can always be put in a print, but because I'm in Jupyter, if you're doing a demo in Jupyter, it's just so great that you have all these controls on here. So we can slice 4 on, and this should look familiar because this is the same as a Python and a lot of other different scripting languages. If we do 4, it goes 0, 1, 2, 3, that's the first 4 in the thing, and it skips some and starts with this one. The first 4 are skipped, and then from there on. You can also do the opposite and go till the 4th one. If we run that, we get 0, 1, 2, 3. Quite the opposite on there. We can do a single item, so we can pick object number 5 on the list, run that, and 5 happens to be 5, because that's the order they're in. And then this one's interesting, because I can do s equals slice, and let's create a slice here, and let's do 2, 9, let's leave a 2 on there. So we'll create an S slice on here. And then if we take our array and we do an array of S, we're taking our slice in there, and let's go ahead and run that. And let's take a look and see what it generated here. First off, we started with 2, so we have 2 at the beginning. We're going to end at 9, which happens to be 8, so it stops before the 9. Remember when we're doing arrays in Python. And then we step 2, so 2, 4, 6, 8. We could do this as 3. Let me run that, and you can see how that changes, 2, 5, 8. And we could do this as, let's leave this at 3, and if we change this to 10, oops, let's make it 12. There we go. And we run that, we have 2, 5, 8, 11. So that's pretty straightforward. It's a very nice feature to have on here where you can slice it and take different parts of the series right out of the middle. So now that we've access to different pieces of our array, let's get into iteration. And this is interesting because my sister, who runs a college data science division, the first question she asks is, how do you go through data? And she's asking, do you know how to iterate through data? Do you know how to do a basic for loop? Do you know how to go through each piece of the data? And in NumPy, they have some cool controls for that. So put this as a markdown. There we go, and run it. And it's called the ND iter. I'm not sure what the ND stands for, but ND iter for iterator. So before we do that, though, let's create an array or something we can actually iterate through. We'll call it A equals NP A range. Let's do something a little funny here, or funky. And we'll do 0, 45, 5. I'm not sure why the guys in the back picked this particular one, but it's kind of a fun one. And if I run that, we do this, you can see we get 0, 5, 10, 15, 20, 25, 30, 35, 40. That's what this array looks like. And that's just from our slice. This is just a slice. That's all that is we created a slice of 0 to 45, step 5. And so we can do with this, we can also do A equals reshape. Let's go ahead and take and reshape this. And since there's 9 variables in there, we'll do a reshape it 3 by 3. So if we run that, whoops, missed something there. That is the A. That really helps. So if we do the A reshape, and we'll go ahead and print that out. We get 0, 5, 10, 15, 20, 25, 30, 35, 40. And then we simply do 4x in our NumPy indicator of A colon, and we'll just go ahead and print x. And let's see what happens here when we run through this and we print each one of those. It goes all the way through the whole array, so it's the same thing we just saw before. We got 0, 5, 10, 15, 20, 25, 30, 35, 40. So it prints out each object in the array. So you can go through and view each one of these. And certainly if you remember, you could also flatten the array and just do for A and that also and get the same result. There's a lot of ways to do this, but this is the proper way with the ND iterator because it'll minimize the amount of resources needed to go through each of the different objects in the NumPy array. And hopefully you asked this question when I just did that. And the question is, how can I change this instead of doing each object? So first of all, let's go ahead and take my cell type, and we're going to mark that down and run it. And so we're going to work on iteration order C style and F style. Remember C because it came from the C programming, and F because it came from the old Fortran programming. So let's give us a reminder. We'll do a print A, and we'll do 4xn np iterate A. But we also want to do this in a specific order. And you know what? I'm a really lazy typer, so let's go back up here. This is the ND iterator. I knew I was missing the ND part of A. And let's do order equals C. We'll print X on there. And let's do that again. And this time order equals F. There we go. Order equals F. And let's go ahead and run this and see what happens here. And the first thing you're going to notice, our original array, 0, 5, 10, 15, 20, 25, 30, 35, 40. When we do order C, that's the default, 0, 5, 10, 15, 20, and so on. And then when you come down here, you'll see F, order F, is 0, 15, 30. So it takes the first digit of each of the subarrays, or the second dimension, and then it goes into the second one, 5, 20, 35, 10, 25, 40. So slightly different order for iterating through it if you need to do that. So we've covered reshaping, we've covered math, we've covered iteration, we've covered a number of things. The next section we want to go ahead and go over is going to be joining arrays. So we need to bring them together. Let me go ahead and take the cell and make it a markdown. Cell type markdown. There we go. And run that. So let's work on joining arrays so we can bring them together and what different options we have. And let's do, we'll do an NP array 1, 2, 3, 4. We'll go ahead and print. Let's do, oops, first. Well, these arrays aren't that big, so let's just go ahead and keep it all on one line, A. So if we run this, first array 1, 2, 3, 4. Whoops, I forgot that it automatically wraps it when you do it this way. So we'll go ahead and keep it separate and print A. There we go. And let's go ahead and do a B. And we'll do 5, 6, 7, 8. And notice I'm keeping the same shape on these two arrays. Depending on what you're doing, those shapes have to match. And let's go ahead and print second array. Do a print B. We'll go ahead and run that. Oops. Missed something up there. Let me fix that real quick. When I was reformatting it to go on separate lines, I messed that up. There we go. Run. All right, so we have first array 1, 2, 3, 4, second array 5, 6, 7, 8. And we'll put a carried return on there. And the keyword we use is concatenate. And if you're familiar with Linux, that usually means you're adding it to the end on there. And we're going to do what they call along axis 0. So we have concatenate AB along axis 0. Let's go ahead and run that and see what that looks like. And so we have 1, 2, 3, 4, 5, 6, 7, 8. So now we have an array that is 4 by 2. Has a nice shape of 4 by 2 on here. And if we're going to do it along the axis 0, you should guess what the next one is. We're going to do it along the 1 axis. And let's see how those differ from each other. Let's just go ahead and run that. And again, all we're doing is adding in the axis equals 1. So we have our concatenate, we have AB, and then axis 1. Remember a couple things. One, these are the same shape. So we have a 2 by 2, same dimensions going in there. You're going to get an error if you're concatenating and they're not. If you have something that instead of 1, 2 is 1, 2, 3, 4, 5, 6 with a 5, 6, 7, 8. They'll give you an error on there. In fact, let's take a look and see what happens when we do that. Let me just take this. 1, 2, 3, 3, 4, 5. And let's run that. And if we come down here, we got there. It says all the input array dimensions except for the concatenation axes M must match exactly. So it will let you know if you mess up. That's always a good thing. Let's go ahead and take this back here, and let's go ahead and run that. And so we have our 0 axes, which is 1, 2, 3, 4, 5, 6, 7, 8. And we bring them together. And you'll see a very different setup here when we do it along the axis 1. We end up with, instead of 4 by 2, we end up with a 2 by 4. 1, 2, 5, 6, 3, 4, 7, 8. And that's just changing which axes we're going to go ahead and concatenate on. What I find is when you're talking about the concatenate or the joining arrays, you really got to play with these for a while to make sure you understand what you mean by the axes. It looks very intuitive when you're looking at it. Axis 0, 1, 2, 3, 4, 5, 6, 7, 8. Axis 1 is then splitting it a different way, 1, 2, 5, 6, 3, 4, 7, 8. When you're actually using real data, you start to really get a feel for what this means and what this does. So if we're going to do that, let's go ahead and look at splitting the array. And do that under Markdown and run it. There we go. So you have a nice little title there. And we'll go ahead and create an array of 9. Let's do NP split. We'll do A, and we're going to split it by 3. Let's just see what that looks like. So if we split it, we get an array 0, 1, 2, 3, 4, 5. We get 3 separate arrays on here. Now remember, we're looking at, let me just print A up here. So we're looking at 0, 1, 2, 3, 4, 5, 6, 7, 8, and then we can split it into 3 separate arrays. And let's take this, we're going to do this right down here. I'm just going to move the A split down here. Instead of the 3, let's do 4, 5, and put that in brackets. And so when we do it this way, we have 0, 1, 2, 3, 4, 5, 6, 7, 8. And that's kind of interesting. I wasn't sure what to expect on that, but we get, when you split an A by 4, 5, you get a totally different setup on here as far as the way it split the array. And to understand how this works, I'm going to change the 5 to a 7. And this will visually make this a little bit more clear. So we had 4 and 5, it went 0, 1, 2, 3, 4, 5, 6, 7, 8. And you see the markers 4 and 5. When we do 4 and 7, I get 0, 1, 2, 3, 4, 5, 6, 7, 8. And so what you're looking at here is the first markers, this is going to go to 4. So there's our first split at the 4, the marker at 4, and then the second split is going to be at position 7. And this is the same thing here. 4, position 5. That's why we're splitting it in those 2 sections. We could also do it 7. Let's just see what that looks like. Run. And you can see I now have 0, 1, 2, 3, 4, 5, 6, 7, 8. So we can split it in all kinds of different ways and create a different set of multiple arrays on here and split it all kinds of different ways. And before we get into the graphs and other miscellaneous stuff, let's go ahead and look at resizing the array. We'll go ahead and take this cell and set the cell as a markdown and run it. Give us a nice title there. And we'll do an array, an NP array of 1, 2, 3, and 4, 5, 6 here. And let's go ahead and just print. Let's go print a dot shape. And we'll go ahead and run that. Whoops, hit a wrong button there. Hit the comma instead of the dot. So we have a shape of 2, 3 here. And this is important to note because when we start resizing it, it's going to mess with different aspects of the shape. And so we'll go ahead and do a print. Scoop in for a blank line. There we go. And let's do b equals np dot resize. We're going to resize a, and let's resize it with 3 by 2. And then we'll just go ahead and print b and print b period shape, not a comma. We'll run that. Oops, forgot the quotation marks around the end. We'll go ahead and run that, and let's just see what that looks like. So we have 1, 2, 3, 4, 5, 6, our original array, with a shape of 2, 3. And then we want to go ahead and resize it by 3, 2. And we end up with 1, 2, 3, 4, 5, 6, and we end up with the shape of 3, 2. That shouldn't be too much of a surprise. You know, we got 6 elements in there. We can resize it by 2, 3 was the original one, and then we're actually just reshaping it is how that kind of comes out as when you resize it like that. But what happens if we do something a little different? And let's go ahead and just take this whole thing and copy it down here so we can see what that looks like. And instead of doing 3, 2, remember last time I did the, to reshape it, I messed with the numbers and it gave me an error. Well, when you resize it, you don't have to match the numbers. They don't have to be the same dimensions. So we can, instead of going from a 2, 3 to a 3, 2, we can resize it to a 3, 3. So let's take a look and see how it handles that. And when we come down here to 3, 3, we end up with 1, 2, 3, 4, 5, 6, and it repeats 1, 2, 3. So it actually takes the data and just adds a whole other block in there based on the original data and repeating it. All right, now at this point, we've been looking at tons of numbers and moving stuff around. What we want to go ahead and do is get a little visual here, because it, certainly you can picture all the different numbers on there, but let's look at histogram. Let's put this into a histogram. Let me go ahead and run that. And to do that, we're going to use the matplot library. So from matplot library, we're going to import pyplot as PLT. And that's usually the notation you see for pyplot. So if you ever see PLT in a code, it's probably pyplot in the matplot library. And then the guys in the back did a nice job, and gals too, guys and gals back there. Our team over at Simplilearn put together a nice array for me, 20, 87, 4, 40, 53, with a bunch of numbers. That way we had something to play with. And what we want to do is we want to do plot the histogram. Now remember, a histogram says how many times different numbers come in. And then we're going to put them in bins. And we have bins 0 to 20 to 40 to 60 to 80 to 100. You might, in here with the matplot library, they call them bins. You might hear the term buckets, where they put them in buckets. That's a really common term. And then we want to give it a title. So the way it works is you do your plt.hist for histogram, your plt title, and your plt show. And we're doing just a single array in here in the NumPy array of A. And let's go ahead and run this piece of code. Take it a moment to come out there. So it's figure size, so it's generating the graph. And you can see we have, and let's just take a look at this. Let me go down a size. There we go. Okay, so now we can see what we're taking a look at here. So between 0 and 20, we have 3 values. So we have a 20 here, we have a 4, and a 11, and a 15. 0, 1, 2, 3. It's actually 4 values, but they start at 0. So remember, we always count from 0 up. And from 20 to 40, we got 20. So it's 1, 42, 3, 4, 5, 6. And so you can see in the histogram, it shows that the most common numbers coming up is going to be between the 40 and 60 range, least common between the 80 and 100. This looks like an age demographics, is what this looks like to me. And you can see where they would have put it in the buckets of different age groups, which would be a nice way of looking at this. Histograms are so important and so powerful when you're doing demos and explaining your data. So being able to quickly put a histogram up that shows what's common and how it's trending is really important. And using that with a NumPy is really easy. And you know what, let's take the same data, and I want to show you why we do bins, or why we have buckets of data. I'm used to calling it buckets. Why we have bins. Let's do it instead of by 20, let's do it by tens and see what happens. And what happens when you do it by tens is you miss out on you can see a nice curve here on the first one, and on the second one it looks like a ladder going up and a plummet, a ladder going up and a plummet, and a ladder going down. So the first would be more indicative of an age group, and the second one would be what you would get if you divided incorrectly. You wouldn't see the natural trend of, I don't know what this would be, maybe how much food they eat. Hopefully not, because I'm in 50, so I'm right in the middle there, which means I eat a ton of food compared to everybody else. But it's some kind of demographic. Maybe it's mental, maybe it's knowledge, because we hit a certain point and then we start losing, our marbles start leaking out or something. So you start off knowing something, and then as you get older you grow more. But you can see here we lose that. You lose that continuity in the thing if you split the histogram into too many bins or too many buckets. And if you actually plotted this by the individual numbers, it would just be a bunch of dots on the graph and wouldn't mean a whole lot. And we've looked at graphs. There turns out are a ton of useful functions in NumPy. I'm sure there's even new ones that aren't going to be in here. But let's just cover some important ones you really need to know about if you're using the NumPy framework. One of them is line space function. This is generating data. So you have a line space, we have 1, 3, 10, and when we do that, we end up with 10 numbers. So if you count them, there's 10 numbers. They're between 1 and 3, and they're evenly spaced. We get 1, 1.222. But these are all, there's a total of 10 here, and it's right between the 1 and 3 range. That can be, there's a lot of uses for that, but they're probably more obscure than a lot of the other common NumPy arrays set up. Then a real common one is to do summation. So we'll do summation where you do, in this case we create a NumPy array of two different arrays, 1, 2, 3, or two different dimensions, 1, 2, 3, 3, 4, 5. And we're going to sum them up under axes 0, which is your columns. And if you remember correctly, columns is the 1 plus 3, 2 plus 4, 3 plus 5, so we have 3 columns. And if we change this, we'll just flip this to 1. We get 2 numbers. So we get 1, 2, 3 all added together, which equals 6, and 3 plus 4 plus 5, which equals 12. We'll set this back to 0. There we go, since we're looking at axis 0. And these probably could have been, some of these could be with our math section. Square root and standard deviation, two very important tools we use throughout the machine learning process and data science. And simply we take the NP array, we have again the 1, 2, 3, 4, 5, 6, 3, 4, 5. I don't know why I need to keep recreating it, probably could have just kept it. But we can take the square root of A. So it goes through and it takes the square root of all the different terms in A. And we can also take the standard deviation, how much they deviate in value on there. And there's a rabble function. We can run that. And NP array is x, we're going to do x equals, hey, we changed it from A to x. X equals rabble. And this sets it up as columns. So we have 1, 2, 3, 4, 5. This is all columns on here. Very similar to the flatten function. So they kind of look almost identical. But we also have the option of doing a rabble by column. And then another one is log. So you can do mathematical log on your array. In this case, we have 1, 2, 3. And we'll find the log base 10 for each of those 3 numbers. And there's a couple of them. You can't just do any number here after log, but there is also log base 2. Log base 10 is pretty commonly used on here. We'll go and run that. There we go. Before we go, let's have a little fun. Let's do a little practice session here on some more challenging questions. So you start to think how this stuff fits together. Right now we just looked at all the basics and all the basic tools you have. So let's do some NumPy practice examples. And let's start by figuring out how do you plot, say, a sine wave in NumPy. What would that look like? And so in this project we wouldn't have to do this because I've already run these, but we'd want to go ahead and import our NumPy as NP and import our matplot library pyplot as PLT. So we get our tools going here. And then we'll break it into two sections because we need our X, Y coordinates in here. So first off, let's create our X coordinates. And our X coordinates we're going to set to an A range. And we want this A range, since we're doing sine and cosine, it's going to be between 0 and 0.1. And then we use our NP, and we actually can look up NumPy stores pi. So you have the option of just pulling pi in there directly from NumPy. It has a few other variables that it stores in there that you can pull from there. But we have NumPy pi, and we generate a nice range here. And let's go ahead and run this. And just out of curiosity, let's see what X looks like. I always like to do that. So we have 0.1, 0.2, 0.3, 0.4. So we're going 0 to, in this case, 9.4, 3 times NumPy pi. Remember, pi is like 3 point something, something, something. So that makes sense. It should be about 9. And we're doing intervals of 0.1. So we create a nice range of data. And then we need to create our y variable. And so y is going to simply equal NP, or NumPy.sine of x. And then once we have our x and y, and if we print, let's go ahead and just print y. See how that, we'll do this. Let's do this so it looks print x, print y. So we basically have two arrays of data. So we have like our x-axis and our y-axis going on there. And this is simply a plt.plot because we're going to plot the points. And we'll do x comma y. And then we want to actually see the graph, so we'll do plot.show. And we'll go ahead and run that. And you see we get a nice sine wave. And here's our numbers 0 through 9. And here's our sine value, which oscillates between -1 and 1 like we'd expect it to. Then for the next challenge, let's create a 6x6 two-dimensional array and let 1 and 0 be placed alternatively across the diagonals. Oh, that's a little confusing. So let's think about that. We're going to create a 6x6 two-dimensional, so the shape is 6x6 two-dimensional array, and let 1 and 0 be placed alternatively across the diagonals. Now, if you remember from lesson 1, we can fill a whole NumPy array with zeros or ones or whatever. So we're going to do NP, create a NumPy zeros, and we're going to do a 6x6, and we'll go ahead and make sure it knows it's an integer, even though it's usually the default. And just real quick, let's take a look and see what that looks like. So if I run this, you can see I get 6x6 grid, so 6x6, 0, 0, 0, 0, 0. Now, if I understand this correctly, when they say 1s and 0 placed alternatively across the diagonals, they want the center diagonal, maybe that's going to stay 0 all the way down. And then the next diagonal will be 1s all the way across diagonally. And then the next one 0s, the next one 1s, and the next one 0s, and so on. Hopefully you can see my mouse lit up there and highlighting it. So let's take a little piece of code here. And we'll do z1 colon colon 2 comma colon colon 2 equals 1. And wow, that's a mouthful right there. So let's go ahead and run this and see what that's doing. And so what we're doing is we're saying, hey, let's look at, in this case, row 1. There's 1. And then we're going to go every other row 2. So we're going to skip a row. So skip here, skip here, skip here. So we're going down this way. And we're going every other row going this way. It's hard to highlight columns. So you can see right here where we're not touching each row, like this row right here is not being touched. Okay, so we're going to start with row 1, and then we're going to skip a row and another one, and so we're going every 2 rows. And then in every 2 rows, we're looking at every 2, starting with the beginning. That's what this thing blank means. So we're going to start with the beginning, and we're going to look at all of them, but we're going to skip every 2. So starting with row 1, we look at all the rows, but we do it by 2 steps. So we go 1, skip 1, 1, skip 1, 1, skip 1, 1. If you left this out, it'd do every one. This would just be 1s. In fact, let's see what this looks like. If I go like this and run it, you can see that I just get 1s. So this notation allows us to go down each row by row, and we're going to do every other row set up on there. And so if we're going to start with row 1, we also, Control Z, try that. There we go. We'll start with row 0. Again, we're going to go each row, step 2. So we'll start with row 0, and we'll go every other row. And this time we'll start with 1, column 1. And again, we go every other one going down. That's what that step 2 is. Skipping every other one. We're going to set that equal to 1. So let's see what that looks like. And you can see here we get our answer. We get 0, 1, 0, 0. But it has the 1s going in diagonals on every other diagonal and 0 on every other one. A little bit of a brain teaser, that one, trying to get that one to work out. So you can see how you can arrange your rows, and here's your step and your different axis on there. And then the next one is find the total number and locations of missing values in the array. The first challenge is to create some missing numbers. So let's create our array Z. We're going to do numpy.random.rand 10, 10. And before we do the second part, let me just take this second part out. And let's just see what that looks like. So let's run that. And there we go. So we have a 10 by 10 random array. It randomly is picking out numbers. And next, we want to go ahead and take our random integer size equals 5. And then we're going to do a random 10 size equals 5. So in the Z, we're going to select a number of random spaces here and set them equal to null value. And let's go ahead and run that so you can see what that looks like. And if we look at the array, we've created 1, 2, 3, 4. There should be a fifth one in here. My eyes may be failing me. So we've created a series of, because 0 to 5, 0, 1, 2, 3, 4. So we got 5, there are different null values on here. And this is kind of a neat notation to notice that we can generate random integers, size equals 5. So this generates 5 by 5 miniature grid inside of this to tell it where to put the nans at. So that's kind of a cool little thing you can do. And then we want to look up and see how many null values are in there. And this is simply just np is nan of z. Simple. So if it is nan, then we want to sum it up. So we're going to sum up all of the different null values on there. Now let's do one more feature in here, which is really cool. Let's go ahead and print the indexes. So np argware np is nan of z. So we're going to create our own another np array. And let's run this, and we'll see here that it comes up with the 4 indexes. So we did count 4 of them up there. It tells you where they are, 1, 9, 2, 0, 4, 6, 5, 4. And then let's go ahead and run this again. Run, there we go. This time I got 5. That's what we get for random numbers. Another fun one that I always like to do is very similar, because we have np is nan z.sum. So we're summing the number of nans. And we can get the indexes, and you can reshape the indexes. But you can also just do, we'll do an INDS where np is nan of z. And let's just print, that. Print INDS. Let's see what that looks like. And it's very similar to what we have 0, 1, 3, 0, 6, 3, 8, 6, 9, 3. But I've split it into 2 different arrays. So we have our x and our y kind of coordinates going there. And what I can now do is I can now do z INDS equals, and at this point you can also, instead of getting the sum, you can get the means or all the numbers and that kind of thing, or the average as it is. So that'd be one thing you could do, and you can pick out the average. That's very common in data science, to get the average and just use that for a value. But we'll go ahead and just set it to 0, and then let's go ahead and print our z and run that. And you can see when we come down here, we have wherever there was a null value, it is now 0. And you can set this to whatever you want. This is another way to replace data or help clean data up, depending on what it is you're doing. So, wow, we covered a lot of stuff. So quick rehash going over everything. We went into there, we looked at array manipulation, changing the shape, how to switch that around. We even had the flatten down there, which remember we have another command lower that's similar. We could change the order by F. Remember, F stands for Fortran, very strange connotation, but there's C and F. C is the standard. and F switches it to a different order. To be honest, I usually have to look it up because I almost never use F, but when you need it, you're like, oh my gosh, what was the other order? Just do a quick Google. So we talked about reshape, making sure that the dimensions are the same. You don't want to have like something that has 12 objects in it and reshape it to 11 and 5 because it doesn't work. It doesn't divide into 12. We can transpose, so we can switch them. So we can go from a 4x3 to a 3x4. Oops, I did that the other way around. 3x4 to 4x3. We covered reshaping the array. We did the roll the axes. You can do some weird things with swapping and rolling axes and transposing the numbers. We dug a little bit into the arithmetic. So we talked about adding, we talked about subtracting, multiplying, dividing. And at this point it's so important we just look up the NumPy mathematics. And you can see here they have just about everything. Your trigonometry, your hyperbolic functions, rounding, sums, products, differences. There are so many, all your different miscellaneous mathematical connotations. So, Google it, go to the main NumPy page and look at the different setups you can do on there. So we covered that, and we did slicing, how to break it apart. We did iterating over the array. We covered joining arrays and how to concatenate. Remember, concatenate just means add on to it. So in this case, how are you adding B onto A is how you'd read that. From Linux, you should catch the concatenate because that's used regularly there. Splitting the array, we talked about how to split the array in different ways. So you can split it in array of arrays, all kinds of different ways to split the array up. How to resize it. And remember, resize does not have to have the same shape, but if you resize it, it will take the data and begin at the beginning and add new rows on if the size is bigger. If it's smaller, it truncates it. It just cuts the end off. We looked at how to do a histogram and how to plot that. We mentioned buckets or bins, as they call them in PyPlot. And then we covered a lot of other useful functions in NumPy. We talked about the line space setup for doing numbers in a series. How to sum the axes up. Again, that's part of the mathematical formulas there that we looked at. There's a sum, there's also means and median. All of those you can compute in NumPy. And you can also do the square root and standard deviation. The ravel function, very similar to the flatten. To be honest, I almost always just use the flatten, but the ravel has its own kind of functionality that it does. And then we went into some NumPy practice examples. We challenged you to create a sine wave in NumPy and how to do that. We're kind of looking for that A range. Remember how we do the A range, and you can have your beginning value, your end value, which they did as 3 times pi, NumPy pi. And we're going to do intervals of 0.1, and then y just equals the NumPy sine of x. There's our math from the math page we were just looking at. Remember that? It's right at the top. And finally we went down here. We had this kind of a little brain teaser, how to do diagonal zeros and ones, playing with the different connotations of the NumPy array. And then we did a random size, and we played a little bit with with the null values, playing with null values. If you're doing any data science, null values are like a headache. What do you do with them? Big sets of data, you get rid of them. Small sets of data, you have to factor something in there, like figure out the average or the median there, and then replace it with that. Pandas really is a core Python module you need for doing data science and data processing. There's so many other modules that come off of it. There actually sits kind of on NumPy, so if you've already had our NumPy array, hopefully you've already gone through the NumPy tutorial 1 and 2. So today we're going to cover what is Pandas. We'll discuss series. We'll discuss basic operations on series. And then we'll get into a data frame itself, basic operations on the data frame, file-related operations on a data frame, visualization, and then some practice examples. Roll up our sleeves and get some coding underneath there. And let's start with just some real general, what is Pandas? Pandas is a tool for data processing which helps in data analysis. It provides functions and methods to efficiently manipulate large data sets. Now, this is a step down from, say, using Spark or Hadoop in big data. So we're not talking about big data here, but we are talking about pandas, and there is some connections. There's like an interface going on with that, so there is availability, but you really should know your pandas, because if you're working in big data, you'll know there's data frames. Well, pandas is a data frame primarily. It has a couple different pieces we'll look at here. And if you've never worked with data frames before, a data frame is basically like an Excel spreadsheet. You have rows and columns. You can access your data either by the row or the column, and you have an index and that kind of setup. And we'll dig more into that as we get deeper into pandas. But think of it as like a giant Excel spreadsheet that's optimized to run on larger data on your computer. And then I said that it's a data frame. So the data structures in pandas are series, one-dimensional arrays, and then we have data frame, two-dimensional array. And it really centers around the data frame. The series just happens to be part of that data frame. And here's a closer look at a pandas series. Series is a one-dimensional array with labels. It can contain any data type, including integers, strings, floats, Python objects, and more. So it's very diverse. If you remember from NumPy we studied, they had to be all uniform. Not in pandas. In pandas we can do a lot more. And pandas actually kind of sits on NumPy, so you really need to know both of those if you haven't done the NumPy tutorials. And you can see here we have our index 1, 2, 3, 4, 5, and then our data A, B, C, D, and E. Very straightforward. It's just two columns, and we have a nice index label and a column label for the data. And then a data frame is a two-dimensional data structure with labels. We can use labels to locate data. And you can see here we had, if we go back one, we had our index 1, 2, 3, 4, 5. So in each one of these series, they would share the same index over there, the row index. So you have your row index df.index, and then you have a column index df.columns. And this should look, like I said, this would be really familiar if you've done any work with spreadsheets, Excel. So it kind of resembles that. This does make it a lot easier to manipulate data and add columns, delete columns, move them around. Same thing with the rows, so you have a lot of control over all of this. Now, we're of course going to do this in our Jupyter Notebook. You can use any of your Python editors, but I highly suggest if you haven't installed Jupyter and haven't worked with it, it is probably one of the best ways for easily displaying a project you're working on. I skip between a lot of different user interfaces or IDEs for editing my Python, and it's just simply jupyter.org, jupyter.org. And then I always let mine sit on Anaconda, anaconda.com. And just real quick, we'll open that up for you. Oops, offline mode. Don't show me that again. But you can see here that I have different tools that I can actually install in my Anaconda, including the Jupyter Notebook, which comes by default. And then I have access to the environments. And again, that's anaconda.com, named after the very large, one of the world's largest snakes, and then Jupyter Notebook. In this case, jupyter.org. And when we're in I'm going to go in here to our Jupyter Notebook, and we're going to go ahead and just do new and a Python 3. And this will open up a Python 3 untitled folder. So diving right in, let's go ahead and give this a title, Pandas Tutorial. And we'll go up to cell, and we'll change the cell type to Markdown so it doesn't execute it as actual code. One of those wonderful tools when you have Jupyter Notebook so you can do demos with this. And let's go ahead and import Pandas, and usually people just call it PD. That has become such a standard in the industry. So we'll go ahead and run that. Now we have our Pandas has been imported into our Jupyter Notebook. And then, we can go ahead and let me do the Control Plus. Since it's Internet Explorer, I can enlarge it very easily so you have a nice pretty view. Whoops, too big. There we go. And whenever you're working with a new module, it's good to check your version of the module. In Pandas, you just use in this case, pd.__version__. That's actually pretty common in most of our Python modules. There's different ways to look up the version, but that's one of the more common ones. And we'll go ahead and run that. We get 0.23.4, and if we go to the Pandas site, we see 0.23.4 is the latest release. And of course, a reminder that if you're going to your environment, you need to install it. So you'll need to do pip install pandas if you're using the pip installer. We'll go and close out of that. And the first thing we want to do is we're going to work with series. A lot of the stuff you do in series you can then do on the whole data set. We need to do what? Create one. We need to manipulate it. Take pieces of it, so query it. Delete, so you can delete different parts of it. So we want to do all those things with the series. And we'll start with the series, and then almost all the code, in fact all the code does transfer right into the actual data table. So we go from a series of a single list of one column, and then we'll take that and we'll transfer that over to the whole table. And we'll start by creating, let's put a, there we go, creating a series from list. And let's just call this ARR equals, and we'll do 0, 1, 2, 3, 4. If you remember from our last one, we could easily do R equals range of 5, which would be 0 to 4. But we'll do R equals 0 to 4, and we'll call this S1, and we'll go PD, and series is capitalized. This one always throws me, is which letters do you capitalize on these modules? They're getting more and more uniform, but you got to watch that with Python. And we're just going to go ahead and do ARR. So we're just going to take this Python list and we're going to turn it into a series. And then because we're in Jupyter, we don't have to put the print statement. We can just put S1 and it'll print out this series for us. And let's go ahead and run that and take a look. And you'll see we have 2 rows of numbers. So the first one is the index. Now it automatically creates the index starting with 0 unless you tell it to do differently. So we get 0, index row 0 is 0, 1, 1, 2, 2, 3, 3, 4, 4. And because it's a series, it doesn't need a title for the column. There's only one column, so why title it? And this also lets you know that it's a data type of integer 64. So we print this out. This is our series, our basic series we've just created. And let's do a second series, PD, and we'll use the same data list. And let's go ahead and do order. We'll give it an order equals, let's do it this way. Let's go index equals order. And it helps if we actually give it an order. So we'll do order equals, and let's do 1, 2, 3, 4, 5. So instead of starting with 0, we're going to give it an order starting with 1. We're going to run that, and we'll go ahead and print it out down here, S2. And we'll see that we now have an index of 1, 2, 3, 4, 5, and that represents 0, 1, 2, 3, 4 in the series. And we're still data type integer 64. And very common as you're messing with NumPy arrays is we can import our NumPy as NP. Remember that from our NumPy tutorials. We can go ahead and create a NumPy out of random with the random numbers of 5. And let's just see what that n looks like, so we can see what our NumPy looks like. So we have some nice random float values here, 2.33, so on. And that's from our last tutorial, the NumPy tutorial 1 and 2. And instead of calling it order, let's call it index. And we're going to set our index equal to A, B, C, D, and E. I want to show you that the index doesn't have to be an integer, so it can be something very different here. And then let's go ahead and create our, we'll just use S2 again. And here's our NP for NumPy, series, capital S, and N is our NP for NumPy. PD for Pandas, there we go, switching my anachronisms. So we have PD.series of N, and we want to do our index equals our index we just created. And then let's go ahead and see what that looks like. S2 is to print it, and let's run that. And we can see here we have a nice series going on. A, B, C, D, and E for our indexes. So instead of it being 0, 1, 2, 3, or 4, we can make this index whatever we want. And you can see the numbers here going down that we randomly generated from the NumPy array. So we used NumPy to create our Pandas series right here. And so continuing on with creating our series, this one I use so often, we create a series from a dictionary. So we have our dictionary. In this case, we went ahead and did A of 1, B is 2, C of 3, D 4, E of 5. So each one of those is a key and then a value. And then we're going to use, let's use S3 equals PD for Pandas, series, and then we want to go ahead and just do D in here. Print out S3 here, and let's go ahead and run this. And you can see we got A is 1, B is 2, C is 3, D is 4, E is 5. And it's still of integer 64 because the actual data is 1, 2, 3, 4, 5, and it's all integer 64, type 64. And the last thing we want to do in the creating section of our series is to go ahead and modify the index, because we're going to start modifying all this data. So let's start with modifying the index of the series. And if you remember, let's do a print this time, S1. I'll go ahead and run this. And the reason I did print is because it only prints out the last variable. So if I put S1 up here and we're going to do another variable back down lower, it won't print the first one, just the last one. And we're going to go ahead and take S1 the index, and we're just going to set it equal to a new index. And obviously, the number of objects in our index has to equal the number of objects in our data. And then because it's the last variable, we can go ahead and just do an S1. And let's run that, and you can see how we went from 0 to 0, 0, 1, 2, 3, 4 as our index. We've now altered it to A, B, C, D, and E. So this would be much more readable, or might be representational of a larger database you're working with. So cool tools. We've covered creating a database based on a basic array, Python array. We've showed you how to reset the index. Then we showed you how to use a NumPy array. So you can put a NumPy array in there. It's all the same, pd.series, a NumPy array, and then we can set the index on there. And the same thing with the dictionary. So it's very versatile how it pulls in data. And you can pull in data from different sources and different setups and create a new series very easily in the Pandas. And then we looked on changing your index. So now we have a new index on here. And then we want to go ahead and do some selection. Let's do some basic slicing, most common thing you'll probably do on here. And we'll just do S1. This notation should start to look really familiar. Again, this is going to put an output, so it doesn't change S1. This just selects it. So we might do A equals S1 and then print A. And you'll see that it just looks at the first three, 0, 1, 2. And we can do the same thing by not having the A in there. I'll go ahead and take that out, but it's just a reminder that it's not actually changing S1. It's just viewing S1. So simple slicing on here. And we can likewise do an append. Oops, before we do append, let's just do a quick kind of fun one. We'll do to -1. And you'll see it covers everything but the E. Of course, you can do -2 on this side. So another way to select it is to go how far from the end. And likewise, we can do a 2 here. A CDE to the end. So it starts at the second one. And another way we can do this is we can do a -2 over here. And that looks at just the last 2 in the slice. So you can see how easy it is to slice the data. And of course, there's no reason to do this, but you could select all of them if you wanted to view all of them on there. Oops, 32. There's not 32, so it's just going to show the first 3. There we go. And then we can also append. So I can take and, let's create another series and append one to it. And if you remember, we had S3. There's our S3. And we have our S1. We'll go ahead and do S1. And let's go ahead and do, let's call it S4 equals S1 append S3. So we're just going to combine those two into S4. And if we go ahead and print S4 on here, you'll now see that we have A, B, C, D, E, A, B, C, D, E, 0, 1, 2, 3, 4, 1, 2, 3, 4, 5, because we started the data at 1. So very easy to append one series to the next. And if we're going to append one series to the next, we need to go ahead and drop or delete one. And drop is the key word for that. And let's just do E, or index E. And so if I run this, you'll see that it'll print it out, and A, B, C, D, there's no E. And remember, all these changes, if I type in S4 again, you'll see that S4 still has E in it. So this change does not affect the series unless you tell it to. So I'd have to do like S4 equals S4.drop E. And there's another way to do that, which we'll show you later on. Let me just cut this one out. There we go. All right, so we've covered all kinds of cool tools here. We have appending, we have slicing, we did all the creating stuff earlier. So you can see here on the setup how easy it is to manipulate the series. So next, what we want to get into is we want to get into operations that happen on the series. Let me go ahead and change this cell to Markdown. There we go, and run that. So series operations, what can we do with the series? And let's start by creating a couple arrays. We'll call it array 1, and we'll do 0 through 7, and array 2, 6 through 6, 7, 8, 9, 5. I don't know why we threw the 5 on the end. Let's go ahead and run those so those load up into Jupyter. And we'll do this a little backwards. We're going to do S5 equals a Pandas series of array 2. So I'm doing this in reverse. And then when we do S5, you'll see that we have 0 to 4. It automatically assigned the index. 6, 7, 8, 9, 5 for our series. And let's go ahead and do the same. And we'll call this S6. And we'll set this equal to PD series for our first array. And if we do an S6 down here to print it out, we'll see something similar. I got 0 through 6, 0, 1, 2, 3, 4, 5, 7 for the data. So those are two series we just created, series 6, 5, and 6. And one of the first things we can do is we can add one series to the next. So I can do s5.add s6. And let's see what that generates. And just a quick thing, if you've never used Pandas, what do you think is going to happen with the fact that this only has 5 different values in it, and this one has 7 values? So let's see what that does. And we end up with 6, 8, 10, 12, 9, and it goes, oh, I can't add this, there's nothing there. So it gives us a null return. Very different than the NumPy that would have given you an error. This instead tells you there's no value here because we couldn't generate one. So we can easily add s5.add s6, and likewise we can do s5.sub for subtract s6, and we'll run that. And on the add, the subtract, and you guessed it, we're going to do multiply and divide next. Again, you can see there's the null values where it can't subtract the two because there's no values there to subtract. We can also do s5 multiply, MUL. They're all 3 letters on these. That's one of the ways to remember how they figured out the code for this. So remember, these are all 3 letters, mul. We'll go ahead and run this, and you can see how they're multiplied together. And then we can also do the s5 div, 3 letters again, s6, and run that. And you'll see here, this goes to infinity because we have 0 in the wrong position. So it actually gives you a whole different answer here. That's important to notice. And then in the null values, because there's no data and it can't actually produce an answer off of missing data. And since we're in data science, let's do S6 median. So let's look up the median data, which is simply median. Sorry for those who are following the 3 letters, because median is not 3 letters. And you can see in S6 is 3.0. And let's do a print here. And we'll do median or average. S6. And let's print max, comma S6. And just like median, there's max value. And if we're going to have a max value, we should also have a minimum value. So let's pop in minimum. We'll go ahead and run this. And you're starting to see something that would be generated like, say, in R, where you're starting to get your different statistics. We have a median value of 3, max value of 7, and a minimum value of 0. And what it does when it hits these null values, if there is null values in there, because we could still do that, we could actually, you know what, let's go up here and do, let's pick this one where we multiplied. Let's go S7 equals, I'll go ahead and print the S7 just so I keep it nice and uniform, so I still have my S7 down there and run it. And then I want to take the S7, because S7 now has null values and an infinity value, and let's see what happens. This is going to be interesting because I want to see what it does with infinity. And we end up with a median of 6, maximum of 27, and minimum of 0, which is correct. It drops those values. So when it gets to there and it doesn't know what to do with them, it just drops those values and then it computes it on the remaining data on there. So that's important to know when you're making these computations, you're looking at min and max and median, you're not going to know that there's null values unless you double check your data for the null values. That's a very important thing to note on there. So just a real quick review on there. We've created our PD series, and we've gone ahead and done addition, subtraction, multiplication, division. All of those are 3 letters, so sub, min, div, add. And then we looked at median, maximum, and minimum. So we're going to go ahead and jump into the next big topic, which is to create a data frame. So now we're going to go from series, and we're going to create a number of series and bundle them together to make a data frame. There we go, cell type, markdown. And we go ahead and run that. So we have a nice title on there. It's always good to have a good title. All right, so our first data frame, we'll jump in with some stuff that looks a little complicated, but we'll break it down. First, I'm going to create some dates. And you know what? Let's just go ahead and do this. I want you to see what that looks like, what I'm creating here. I've created a series of dates, PD date range, and we're going to use these for the index. Okay, so when you look at this, you'll see that it's just, basically it comes out kind of like a basic Python list or a NumPy array, however you want to look at it, with our different dates going down. And we've generated 6 of them. And it's going to have whatever time it is right now on the thing for the date for the time. That's that time stamp right there. And then you'll see we have 11/19, 2008, 11/20, 11/19, and looking into the future there. So that's all this is generating a series of dates that we're going to use as our index. And this is a Pandas command, so we have a date range, which is nice. That's one of the tools hidden in there in the Pandas that you can use. And next we're going to use NumPy to go ahead and generate some random numbers. In this case we'll do the np.random.random in 6,4. You can look at this as rows and columns as we move it into the Pandas. And of course you could reshape this if you had those backwards on your data. But we want the 6 to match the rows, and we have 6 periods, so our indexes should match along with the rows on there. And then, you know, before we do the next one, let's go ahead and just print out our NumPy array so you can see what that looks like. Here we have it, 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6. 4 by 6. So it's a nice little setup on there. And since working with data frames can be very visual, let's give our columns, we have 4 columns. And we're going to give them names, A, B, C, and D. So now we have columns on there also. And then let's put this all together in a data frame. And we can actually, you know what, let's do this. Since I did it with everything else, let's go ahead and do columns. And you can see there's our columns on there. And we'll go ahead and do df1 equals pandas dot data frame. And note that the D and the F are capitalized. Series, it was just the S, and I always highlight this because you don't know how many times these things get retyped when you forget what's capitalized on there. It's a minor thing. You'll pick it up right away if you do a lot of it. And the first thing we want to do is we want to go ahead and take our NumPy array, because that's what we're going to create our data frame off of, is the NumPy array. And then we want our index equal to our dates. So there's our index in there. And then we also have columns equals columns. And then finally, let's see what that looks like. Now remember, we had all that different data that just looks like a jumble of data. We have our column names and everything else. Our NumPy array, kind of just a jumble array over there, 4 by 6. You can sort of read it. But look how nice this looks. I mean, this is, you come into a board meeting, you're working with your shareholders. This is pretty readable. This is, you know, this is our date. This is our A, B, C, D, whatever it is. Maybe each one of these dates has your leads, closures, lost leads, total dollar made, you know, whatever it is, if it's in a business. Maybe it's measurements on some scientific equipment, weather searching material, you know, where this is like high of the temperature, low of the day, humidity of the day, whatever it is. So you can see that we can really create a nice clear chart, and it looks just like a spreadsheet. You know, we have our rows, and we have our columns, and we have our data in there. Now this one I use all the time. If we're going to create, we can create it like you saw here with our NumPy array. Very easy to do that and reshape it. You can also create it with a dictionary array. So here we have some data, and let me just go down a notch so you can see all the data on there. We have an animal, in this case cat, cat, snake, dog, dog, cat, snake, cat, dog. We have the age, so we have an array of ages. We have the number of visits and the priority. Was it a high priority? Yes, no. And then we're going to take that, we're going to create some labels. We have A, B, C, D, E, F, G, H, I. And what I want you to notice on this is we have a title, animal, and then we have basically a Python list. And these lists, they don't necessarily have to be equal because we can have non-data, you know, np.nan, NumPy array, null value. But we want to go ahead and create labels that are equal to the number in the list. So A, the first cat, B, the second cat, C, the snake, D, the dog, and so on. So we'll go ahead and create our labels, which we're going to use as an index. And we'll call this df, let's do it this way. We'll call this df2 equals PD for pandas data frame, and then we have our data just like we did before, and then we have our index equals labels. And if we're going to go from there, let's go ahead and print it out so we can see what that looks like, df2. So let's go ahead and run that. Another, again, you have a nice, very clean chart to look at. We've gone from this mess of data here to what looks like a very organized spreadsheet, very visual and easy to read. Animal, age, visits, priority, and then A through J, cats and all your different animals, so on and so on. And then when you do programming, a lot of times it's important to know what the data types are. So we can simply do df2 dtypes. And if we run that, we can see that our animal is an object, because it's just a string, but it comes in as an object. Age is a float 64, integer 64, and then priority again is just an object. And exploring this one's very popular. Let's go df2 head, and if we print that out, the df2 head returns the first 5. And we can change this. You don't have to do 5. You might want to just look at the top 2. Maybe you want to look at, let's see, let's do 6. So maybe we want to look at just the top 6 in the database, in your data frame. And you can actually, this creates another data frame. So I could have a df3 equal to df2, and this now takes the df2 and just the first 6 values. So if we do df3, run, get the same answer. And if we do the head of the data, we can also do the tail. It's the same thing. df_tail, you can look at the last, we'll just do the tail, which by default does 5, the last 5. And of course you can just look at the last 3 of those real quick just to see what's at the end of the data. And this is the tail. I love doing the tail of 1 because I'll have like the index or something like that, and it will just show me the last, whatever the last entry was. You know, looking at stock values, and I might want to look at just the last 5 days of the stock values. I can do that with the data frame tail. And some other key things to look up are the index. So we can do df2.index. And I want you to notice that this isn't a call function. So if I put the brackets on the end, it'll give me an error because index is not callable. It's just an object in there. So we do df2.index. There's also columns. So we can go ahead and let's print this. Remember, the first one's not going to show unless I print it, and then df2 columns. So now we can see that we have our indexes and we have our columns listed here, df2.columns, animal, age, visits, priority. It tells you what kind of object it is, or what kind of data type it is, and they're both object. And then finally df2.values. And again, there's no brackets on the end of df2.values because this is an actual object, it's not a callable function. So we'll go ahead and run that, and it just displays a nice array. A very easy way to convert this back to a NumPy array, basically. So before I go into the next section, let's just take a quick look at what we covered so far with the data frame. We came up here, we created our data frame. We did it from a NumPy array first, setting the columns and the index. The index setting it up is the same as when we set up the series, so that should look very familiar. So is the whole format, the NumPy array, the index dates, and the columns. And remember, in our NumPy array, we're looking at row, comma, column. So 6 rows, 4 columns is how that reads in the data frame. And we went ahead and also did that from a dictionary. In this case, animal was the column name with all the data underneath that column, and then age with that data, visits that data, priority that data. And then of course we added our labels in there for our index. So there's no difference in there, but it automatically pulled the column names. Important to know when you're dealing with a data frame and importing a data frame this way. And then we did looking up D-type. We looked at head and tail, looking at your data really quick. We also did index and columns and values. And note these don't have the brackets on the end. So the next thing we want to do is go ahead, since we're dealing with data science, is we want to go ahead and describe the data. So we have df2.describe to do that, and we're going to manipulate it in just a minute, but let's just see what this generates. And you can see right here we have age and visits. So looking at our data from up above, let me just go all the way up here. Animal, age, visits, priority. And it does a nice job generating your age versus visits, which has all the data. You have your count, your means, your standard deviation, your minimum value, 25% are in this group, 50%, 75, and your maximum value. So this will look familiar as a data science setup with your describe for a quick look at your data frame data. So let's start manipulating this data frame and moving stuff around, and we'll start with transposing. And it is simply capital T for transpose. And when we run that, it flips the columns and the indexes. So now the indexes are all column names and the columns are all indexes, animal, age, visits, priority. So if we had come in here with our data shaped wrong, up above where we had a 4x6, we can quickly just swap it if we had it backwards. Not a big deal. And we can also sort our data, something that you can't do, which is more difficult to do with a lot of other packages. In the data frame, it's really easy to do. Take our data frame df2, and we're going to sort underscore values by equals age. And so when we run this, you'll see the default is ascending. So we have 0.52, 2.53, and everything else is organized. So if you look at your indexes, they've been moved around because each index, it moves the whole row, not just the one piece of data is not being sorted. So a very quick way to sort by age our different data in the data frame. And in addition to sorting it, we can also slice the data frame. So I could do df2, and this should look familiar from earlier. We'll just do 1 to 3. So we're going to pull out, oops, it does help if I use a df instead of just d. And we're going to pull up just between 1 and 3. So we have not 0, which is A, but we have B, which is 2, or B, which is 1, and C, which is 2. So 1, 2, and then it does not include 3, which is the standard in Python. And we can even do something like this. We can combine them, which is always fun, because remember this returns a data frame. So if I take df2 dot sort values, and we'll do by equals age. This is just kind of fun. And then I'm going to slice it. There we go. Double check my typing and run it. And now you should see FA, because FA are now 1 and 2 on there. So you can very quickly create a whole string on here which narrows it, that you can sort it, then slice it, and do all kinds of fun things with your data frame. We'll just go back to the original one. Run. There we go. And if we can slice it by row, we can also query the data frame. So we can do df2. And this is a little different because I'm going to create an array within an array. And in this case, we're going to look at, let's do age, comma, visits. So look at the different format in here. We have 1 to 3. So we've done this by slicing by an integer value. And then on here, I've done df2 age, comma, visits in an array. And when I run this, you can see that we get just these 2 columns on here. We get age and visits. So it's a quick way to select just 2 columns or select number of columns you're working with. And if you saw up there, we did the slicing. Almost identical to slice is iLocation, which uses the integer location 1, 3. There's a push in Pandas to move to this particular setup instead of doing just a regular slice. And that's because this can be confusing when we slice 1 to 3 and then we select age and visits. So there is a push to go ahead and move to an iLocation, which does the same thing. You can see here BC, it's the same as up above. There's also a copy command, so we can do df3 equals df2 copy. We're just going to create a straight copy of it. And of course, if we do df3, it'll be the same as a df2 on there. So df3 equals df2.copy. And then let's do df3.isNull. So we're looking for null values. And this will return a nice map, and you'll see that everything is false, except when you go up here under the cat or H, they had a null there. And so if we go, they have a couple up here also underneath of, let's see, the dog. Okay, there's a bunch of nulls in here. There's D up here. So let's look at D down here, and you'll see false, true. There it is. There's our null value. So we can create a quick chart of null values. You can use this to do other things. We can leverage that null value to maybe take an average or something and fill those null spaces with data. And we can also modify the location. So here's our df3 location. And notice this is location, not iLocation. iLocation has I for integer. Location uses the, in this case, the variables on the left. And what we can do on here, and we'll go ahead and just set this equal to 1.5, and then let's pick a spot. Let's go back up here where we had, let's do F age, let's see, what was I looking at? Oh, here we go. Let's do F and age. And up here, F is set to age of 2.0. And we find out that that's incorrect data, so we go ahead and switch to df3 equal, and then we go ahead and print out our df3. And if we go to F and age, it is now 1.5. So we're just changing the value in the df3. And this is changing the actual data frame. Remember, a lot of our stuff we do a slice, and like it returns another data frame. This changes the actual data frame and that value in the data frame. So we've covered location and iLocation is null, making a copy. Here's our iLocation, which is equivalent of a slice, and also selecting columns. So now we want to just take a little detour here, and let's look at df3 means. And this is kind of nice because you can do this. You can either do this you can select a single column here, by the way. You can just add the column selection right here like we did before. So we could have age, Look up the mean, that just creates a series. If I run that, there's our age. But if I take that out, instead of selecting it, we can do the whole setup, and it has age and visits. So why doesn't it have priority or animal? Well, those are not integers, so it's really hard. They're non-numerical values. So what is the average? I guess you could do a histogram, which probably we'll look at that later on. But the only two things we can really look at is age and visits, and we have the average or the mean on the age is 3.375, and the mean on visits is 1.9. And let's do df3 visits. We'll go ahead and still the visits again. And you remember all those different functions we looked at for a series? Well, we can do those here. We can do the sum. So if we run that, we'll see that these sum up to 19. We could also look up minimum. If you remember that from before, the minimum is 1, max. So all that functionality is here. I'll just go back to summing it up and adding it all together. So real quick, we've shown you how to take the series operations and put them into the data frame. And then we can actually, this is an interesting one, we can just do df3 sum, run, and you'll see the different summations on there. It just combines them. I like the way it just combines the strings on there for priority and animal. We've looked at is null. We've also looked at copying, along with the different slices which we talked about earlier. So let's talk about strings. Let's dive into the string setup on there. And let's go ahead and create a string series. String equals PD series. And we just put it right in there. We have A, C, D, A, B, A, C, A. Popped in a null value. Cow and owl. I don't know why they picked cow and owl in the background. Someone must like those animals. And of course we can just do string. If we run that, you'll see, leave the R out, we'll get an error. But if we put it in there, you'll see that we have a simple series. 0A, 1C, 2D. And it automatically indexes it 0 to 8. And then we can go string dot lower. So when we're talking about our data frame, in this case, or our data series string, in this case, we use the string function, str, and we're going to make it lower. And if we go ahead and put the brackets on there, and you'll see that we've gone from capital A, capital C, so on to ABC. And baka, CBA, cow, owl, they were all lowercase already. And of course, if you want to go lower, you can also do upper. And we'll go ahead and run that. And you can see we now have ACD, AAA, baka. Everything's capitalized except for the null value, which is still null. Alright, so we looked at a few basic string. You can see that string functions upper and lower. We're going to jump into a very important topic. I'm even going to give it its own header on here because it's such an important topic. What do you do with missing values? Panda has some great tools for that, so we'll dive into those. We'll work with df4, and if you remember the df copy from above, we're just going to make a copy of df3. And let's just take a quick look at the data we're working with. Oops, df3, forgot the 3 on there. There we go. So here we have our cats, snakes, and dogs. Hopefully not all in the same container, because that would be just probably mean to all of them. So we made a copy. We're going to be working with df4. And the reason we made a copy is we want to go ahead and fill the data. And we just simply do fill NA, and then we're going to give it the value we want to put in there. We'll give it the value 4. So I can run in here, and you'll see now that df4 now has where the NA was, it's filled with the value of 4. Same thing down here. A lot of times we'll compute the mean first. So I might do a mean age equals df4, and then we want to go ahead and do age and dot mean, and then I'll do something like this, df4. I only want to select the age, and I want to fill that with the mean age. And I run in there, and you'll see that our df4 age now has the means in there. Just a quick way of showing you how you can combine these. Let me go back to our original one. There we go. And run that. And keeping with good practices, df5 equals df3.copy. And then we'll print our df5, which should be the original one. And then on the df5, we can now drop our missing data. I'm going to simply drop NA, and we're going to use how equals any. So I'm going to drop any row that has missing data in it. And you'll see we had D here with missing data and H. And then let's go ahead and see what df5 looks like when we do that. There we go. And there it is. D is gone and so is H. So we create a new data frame off of this, missing those values. Now, if you have a lot of data, dropping values is a good way to take care of it because you don't miss some data. If you have not a whole lot of data, you're working with like the iris data set or something like that, or something small, you want to start trying to find a way to fill that data in so you don't lose your computational power of the data you got. So just a quick look at processing null values or missing values. You can fill them, usually with the means. Some people use medium or the mode. There's different ways you can fill it. One way is means. And we can also just drop those rows. Those are the two main things we do with missing data. Here we go. We're going to cover next. I so love data frames for this. File operations. It saved me so much time because they have so many different tools for bringing data in and saving data. So when we're looking at the data frame file operations, it's really streamlined. I don't know how many times I'll go on to different data downloads and they'll have Panda download standard on there just because it's so widely used. So let's start with the most common file is a CSV. So we have df3 to CSV or animal. And let me just show you what the folder is going into. Right now I have some untitled and a few things in here, but nothing labeled animal. So we go ahead and run this, and this has now saved the animal to my hard drive. And you can now see the animal folder up here, and if I, let's do edit with a notepad. Oh, let's open it up with just a regular notepad. There we go. Or WordPad. If I open that up, you can see it's comma separated. Our titles, they don't have an index on the categories on the top. And the index, comma, and then all the different data is separated by commas. Standard CSV file on there. And if we're going to send it to CSV, and notice the format is .to_CSV. And it's just the name of the file we're sending it to. You can also put the complete path. By default, it's going to go whatever the active directory this program's running on. That's why those other folders are in there. So we have our df3 to CSV, and then if we're going to put it in there, we want to also get it back out. And we'll call this one df_animal equals pd read_CSV. I always have to remember it's to_CSV and read_CSV. I always want to do like a capital in there and not the underscore. We're going in here again, it's the active directory. So if I now do print out my df animal, and let's just do the head. We only want to look at the first 3 lines. So if I go ahead and run this, we'll see the first 3 lines and they should match up here what we saved to our CSV. So very easy to save and import from our CSV files on here. And it turns out df3 also has a to Excel. They actually have a lot of different formats, but old school Excel was real popular for so long, still is. We can go ahead and save it as animal.xlsx. We're going to call the sheet named sheet1, and then I can also do df, we'll call it animal2, and this one's going to come from, and the same format on here. There we go. So we still have our animal xlsx, the sheet1, that's where it's coming from. Index columns equals none. So we're going to suppress the indexing on the columns. NA values, and it'll just assign it's 0 on up on your indexes. So if it says index columns equals none, that's what it does. And then we've added null values because there's null values in here, and we want to just make sure that they're marked as NA. And we'll go ahead and just print out the animal2. There we go. And let's run that. Let's make this. No, let's just do the whole thing. So we'll go ahead and run that. And it probably doesn't help that I completely forgot the read. So animal2 equals pd.read Excel. There we go, Excel. So now we go ahead and run it. And what we expect is happening here. We have the same data frame on here. And if I flick back to my folder, you can now see that we have the animal. One of these is in Excel, and one of these is a CSV on here. And so there's our 2 file types on there. And they have other formats. These are just the 2 most common ones used, and I don't know how many times I've had stuff from Excel I need to pull out. If you've ever played with Excel, it's a nightmare in the back end because of the way they do the indexing. So this just makes it quick and easy to pull in an Excel spreadsheet. So we looked at 2 different ways to bring data in and save it to files. We've looked at all kinds of different ways of manipulating our data set and slicing it and creating it for our data frame. Let's get in there for your visualization. Always the big thing at the end, because 1, it lets you check to see what you did, make sure it looks right. And then also, if you're going to show somebody else, it makes it very clear what's going on if they see something visual. So this is where a really important part of data science is. So let's go ahead and bring in our tools. We're going to do import NumPy as NP. We want to make sure we have our ampersand matplot library in line. This just lets Jupyter know that we're going to print it on this page. If you're using a different IDE, you don't really necessarily need that, but this does help it displays correctly in Jupyter Notebook. And if you remember for earlier, we could create a, we're going to call it TS. We're going to create a pandas, which are cute cuddly creatures, versus a pandem, short for pandemonium? No. So we have TS equals PD series, and we're just going to create a random setup of 50. We'll do an index. We'll set it equal to the pandas date range today. Periods equals 50, so the 50 should match. And I want you to notice something here. I did not import the matplot library. Why? Because it's already in there. Pandas already has its built-in connection and interface with matplot library, so you don't have to import it. And we'll go ahead and do TS equals TS dot cumulative sum. We're going to do the cumulative sum. So a little reformatting there, and we'll go ahead and plot it. And let's take a look at what that looks like. So we have a nice graph here. We have the dates on the bottom. We've set this up so we have a nice range between, in this case, -4 to, looks like about 2 maybe, or 1, -4 and 1. So what we've done here, we plotted a basic series, just a single row of data, and we've set indexes on there. But we can also do the whole data frame on there, and let's see what that looks like. So first, let's go ahead and create the data frame. We have here random numbers, so we're going to do 50 by 4, and then we'll go ahead and create columns A, B, X, and Y. Just because we can. Index is a ts.index on there, so we're going to use the same index as before, just to keep it nice and uniform. We've already generated the dates to go with it. And then we can do, just like we did with the series, we can also do with the data frame, df equals df cumulative sum. So we're going to sum the whole data frame. And then we'll do simply df plot. And let's push that in, and let's go ahead and run this. And look how easy and quick that was to generate a nice graph with all the different data on there. So we have our shared index, we have the shared columns, and then we have the different data from each one that we can easily look at and compare. So very quick way of displaying data. You can imagine if you were working in, I think I mentioned stock earlier because I've been doing some analysis of stock lately. So you'd have your date down here, and then you would have stock A, stock B, stock XY, whatever it is. And you can put them all on one chart and see how what they look like next to each other. And this isn't too far off from what some of those graphs look like, and this is just randomly generated. So stock has a lot of randomness in it, which is one of the reasons I actually play with it for doing some of my models for testing them out. Now, there are a lot of features in Pandas. So we're going to show you one more thing on here. There's some of the things, like I didn't go too deep. We looked at the top two for importing data from a CSV and from an Excel spreadsheet. Showed you how to quickly plot the data. There's more settings in there you can do. We're going to do one more thing down here, and this is kind of a fun one. Change this to a markdown and run that. So how would you remove repeated data using Pandas? And this is where you have a data set that comes in, and maybe it's feeding from one location, and instead of noting that it's repeated the date, like, let's go back to stocks. That's a good visual. We have the stocks from the 23rd. And it adds another row, and it's the same row. It's importing the 23rd again and again. So now you have that data repeated 3 times, and you need to go back and figure out how to get rid of it. How do you track that down? So let's start by creating a quick database, or data frame. Not a database. I keep saying database. It's a data frame. And we'll just make this data frame using our dictionary going in. This data frame only has one data series in it, which is fine. So if we do df to print it out, you'll see A, 1, 2, 2, 2, 2, 4, 4, 4, 5, 6, 7, and so on. And so how would you remove that? Well, there is a neat feature in data frames called shift, along with another feature that lets us select just certain information. And we'll go with the location function. Put that in brackets. Remember that from above, location. And then in the location, let me just spread this out a little bit so it's real easy to read. In fact, I'm going to go upscale on that since we're doing a little bit more complicated here. What you can see on the location is I have dfa.shift. So this is going to shift up 1 by default. You can actually change this to 2 or 3. You can even do a -1 and it shifts the other way. But it's going to shift up by 1 by default. And it's going to say if that does not equal df of a, then we want that. And if you look down here, we had 1, 2, 2, 2, 2, 2. When we run this logic on here and we do the shift, it now gets rid of all the duplicates. So we went from 1, 2, 2, 2, 2, 4, 4, 5, whatever it was. Here it is, 1, 2, 2, 2, 4, 4, 4, 5, 5, 5, 6, 6, 6, to 1, 2, 4, 5, 6, 7, 8. And you'll see on the index, it just deletes them out of there so the index stays the same. Obviously, you don't want the dates to change if you're working with an index data setup. So it just deletes those duplicates out of there. This is just a quick way to introduce you to, 1, the fact that you can add logic gates into here. And 2, the iLocation allows you to use shift. So there's the shift function, and then the iLocation selects that based on true or false. Wow, so we've actually covered a lot today in Pandas. We've really covered into the basics of selecting your different series out of your column, out of your data frame, how to index rows, how to slice, how to plot. Hopefully you'll take this beyond that and start combining these different things, and you can create long strings and really explore your data, generate some nice graphs. If you're in Jupyter Notebook, it's a great demo to show others. And I didn't know this about Jupyter Notebook. You can do this in Jupyter Notebook, and then you can download. And I never really looked too closely at all the downloads. But you can download it as an HTML and post it to your blog. So it's got a neat feature in there. But any of this is really powerful tool. All of this is really powerful tools for doing your data science.
So as you can see, I'm using Jupyter Notebook for the Python. Okay, so here what I will do, I will go to new and this Python 3. Okay, so here first I will rename it to Pandas for data analysis. Okay, then rename it. Okay, so already everyone know Pandas is a Python library that provides extensive means for data analysis, right? Data scientists often work with data sorted in the table formats like .csv, .tsv or XLX. Okay, so Pandas makes it very convenient to load, process and analyze such tabular data using SQL-like queries. Okay, so in conjunction with Matplotlib and Seaborn, Pandas provide a wide range of opportunities for the visual analysis. Okay, you can make charts and all, right? So the main data structure in Pandas are implemented with series and data frame classes. So now let me import NumPy first, okay, as np. Then I will write import Pandas as pd. Why I'm writing as np and as pd? Because I don't want to write Pandas and NumPy again and again and again. So I gave the short form, you can say. Okay, so here I will write just pd dot set underscore option display dot precision. Okay, then I will write comma 2. Okay, where are it? Okay, fine. So we have imported Pandas and this NumPy library. So now what I will do, I will demonstrate the main method in action by analyzing a data set on the churn rate of telecom operator. I have like one data set named telecom churn, okay, operator clients data set. So now let's first import it. Okay, so I will write here df equals to, df means data frame. You can give any name. Okay, df pd, as you can see here, pd means pandas dot read underscore csv, then telecom churn dot csv. So you can find this data set from the description box. Okay, in the description box below, right? Then I will write here df dot head. What does this do, df dot head? It will show you, the first 5 lines using the head method of the data set. It will show you first 5 lines of the data set head. And if you will use tail instead of head, you can see the last 5 rows of data set. Okay, if I will write here df dot tail, you can see the last 5 rows of the data set. Fine. Yeah, so on our data set we have state, account length, area code, international plan, voicemail, this. Okay, and the churn rate is false. Fine. So now what I will do, I will recall that each row correspond to one client, an instance, and the columns are the features of the instance. So now let's have a look at the data dimensionally, features, names, and the feature types. Okay, so how many columns and rows we have? Fine. So I will write here print df dot shape. Okay. So now we have 3,333 rows and 20 columns in our table, in our data set. Okay. So now let's try printing out the column names using columns. Okay. So for that, what I will do, I will write here print. So these are all the functions used in Pandas. Okay. Then df dot columns. Okay. So now you can see here we have 20 columns right here, 20 columns. Okay. So here state is one column, account and 3, 4. These are the all columns name. These columns name. Fine. So now let's use another function called info, which will give you some, it will give you some general information about the data frame. Okay. So here I will write print df dot info. Okay. So yes. So now you can see class is pandas, core frame, data frame, then this much entries. Okay. 0 to this 3,332. Okay, column name and the non-null values. Non-null count is okay 0, and the data types you can see. This is object, this is int64, 64 object, floating type. Okay, so there are 4-5 type of data sets here. Okay, bool is there, float is there, okay, int is there, and the memory usage you can see 498.1 plus KB. Okay, and then bool is 1, float 64 type is 8 columns, then int 64 8 columns, and object is 3, right? So here these bool, int 64, float 64, and object are the data types of features. Already I told you. So we can see that one feature is logical. Okay, that bool one is logical. Where is the bool? Yes, this one. Churn rate is logical. Okay, logical means true, false. Okay, and the 3 features are of the object type. You can see this state. These are the object, and the 16 features are numeric. Okay, float is also numeric plus variable, right? So with this same method, we can easily see if there are the missing values. So here are, none, because each columns contain 3,333 observation. See, every column is same, and you can see null count is non-null. Okay, so here you can see we don't need any cleaning and that type of thing. Okay, so we can change the column type with the as type method. There is one more method. So let's apply this method to the churn feature to convert into int64. Got it? So for that, what I will do, I will write df, then I will write churn. Please note that no spelling mistake while writing the column names. Okay, equals to df churn. Okay, C is capital dot as type int64. Fine. So now we have convert this bool to int64 now. Okay, so now what I will do, I will use one more method. Okay, let me run it first. Okay, it's no. issues. Now what I will do, I will write here df dot describe. Yeah. So now, so the describe method shows basic statistical characteristics of each numeric feature, int64 and float64. Okay. Count is there for the particular column, the mean, standard deviation, minimum value 25%, 50%. This is the max value. Okay. Okay, now you can see the churn 0 and 1 to 1. Okay. So, and the number of non-missing values, mean, standard deviation, range, medium, everything is here. Using describe, you can just find it. Okay. For every column, it will give you. Okay. Count, how much count, and mean of this particular account length and the area code, like this. So now, so in order to see the stat of non-numeric feature, so one has to explicitly indicate data types of interest in the include parameter. Okay, I will use the include parameter. So at first I will write df dot describe include equals to object comma bool. Okay. So now you can see the count is 333 and unique values are the 51, and the top is this and the frequency is this. Okay. So I am here seeing the stat of non-numeric features. Okay, this is like state, international plan, and the voice plan, like this. Fine. So for categorical data like type, object, and the Boolean type bool feature, we can use the value counts method. So now let's have a look for that also. So I will write df churn dot value counts. Okay. So this is some data, right? So now what I will do, so there are, okay, fine. So now what I will do here, I will normalize it. Churn dot value counts normalize equals to true. Okay. So we have 2850 users out of 3033 are loyal. Their churn value is 0. Okay. And to calculate fractions pass normalize is equals to true, I have did that to the value count function. Okay. So here you can see 0 and the 1 value counts, right? So now let's go for the sorting data. So what is sorting? So a data frame can be sorted by the values of one of the variables like columns. So for example, we can sort this table by total day charges using ascending or in descending, right? So now I will do here df. Okay, first I will let me write here sorting. Okay, df dot sort values by equals to total day charge ascending equals to false dot head. Dot head means I want to see the top 5 rows. Okay. So now what I did, total day charge. Okay, total day charge I have sorted in this. Ascending equals to false means I have sorted into the descending order. Okay, and the top 5 rows are this. Okay, 59 is the maximum, 59.64. Fine. So now, like, we can also sort by multiple tables, so in one go. Okay, so let me do it. Df dot sort, same thing I have to write, values by equals to churn. Okay, let me write this. Yeah, churn, comma, then again total day charge, comma, ascending equals to true, comma, false. Then I want to see, okay, let me write the same dot at. Okay, first I will show you this 1 1 1 1 1. Okay, then let me change it. See, it's sorted now. Fine. So these are the top 5 as per these two columns, churn and the total data charge column. Okay, so now we will perform some indexing and retrieving data. So a data frame can be indexed in a few different ways. Like to get a single column, you can use data frame name. Okay, and so now let's use this to answer a question about the column alone. So let's take one question like, what is the proportion of churned users in our data frame? Okay, proportion. Okay, df dot, we will do simply, we have to find the mean. I will write churn dot mean. That's it. Okay, so 14.5% is actually a quite bad for a company, such as a churn rate can make the company go bankrupt, right? So Boolean indexing with one column is also very convenient. So the syntax is, I will write here df, then again df churn equals to 1, then dot mean. Okay, so here what I am finding is what are the average values of numerical features for churn user. Okay, see, account length one, just ignore this warning. Okay, so account length is 102.66, area code is this, right? So now what I will do, I will find one more thing. So like we will find how much time, like in average, do churn users spend on the phone during daytime. Okay, df then churn equals to 1, then total day in minutes. We have this column, right? I hope so. We have this column, total day minutes. Okay, fine. Yeah, dot mean. Okay, so how much time an average churn user spend on the phone during daytime is 206. Okay, almost 207. Okay, so now let's take one more question, like what is the maximum length of international calls among loyal users? Okay, loyal user means where churn is 0, like who do not have the international plan. So here for that I will write df and df churn equals to 0. Here I will write and df, okay, I will, okay, international plan equals to no. because there is, see, you can see the international plan, no, yes, no, yes, no. Okay, no, then total international minutes. Okay, this. Okay, for the confirmation, let me copy it and paste. Okay, no issues. Dot maximum value. Yeah, so 18.9. Okay, so 18.9 is the maximum length of international calls among loyal user, whereas churn is 0 who do not have the international plan. Okay, so indexing, data frame can be indexed by column name, I told you already, or the row name, or by the serial number, you can say, of a row. So there is one method, LOC. Okay, method is used for the indexing by name, while iloc is another method for indexing by the number. Okay, first I will show you df dot, here I will write indexing, df dot loc comma state, then area code. Okay, so in this first case, we can say I gave the values of the rows with the index from 0 to 5, like inclusive, and the column labeled from the state to area code inclusive. Okay, so this is how you can perform indexing. Okay, using by name. Okay, if you want indexing by the numbers, you have to use iloc instead of this loc. Iloc means location. Okay, don't get confused. 5 comma 0 to 3. Okay, see, you got the same almost, right? Yeah, this is 0 to 5. Okay, and this is 0 to 3. 0 to 5 means 1 2 3 4 5, and 0 to 3 1 2 3. Fine. Yeah, so what if we need the first or the last line of the data frame? So we can also do that. So here simply you have to write simple thing, df -1. Okay, that's it. See, this is the last line, -1, last line. Fine. So if you want to apply something to all the columns, so there is one more function which is apply. So how to do is df dot apply np dot max. Okay, right, it gave me all the maximum values of the particular table, sorry, particular column, not table. Okay, so this is how you can do this. So this apply method can also be used to apply a function to each row, I already told you. So to do this, you have to just specify the axis, or the lambda function are the very convenient in such scenarios. Like for example, let me give you one example, df, then df state, let's use the state. Okay, then dot apply lambda state, and state 0 equals to w, which is starting from w. Okay, then dot, I need only 5 rows, dot it. Okay, so the state is starting from w, here it is. Okay, top 5, right? So yes, so there is one more function, map method, which is used to replace the values in a column by passing a dictionary or the form, right? So map function D equals to no, okay, it is false, then yes is true, right? Then DF international plan equals to DF international plan dot map D. Okay, DF dot head. Fine. Okay, there is some international plan. Okay, P is small. That is why I was saying, please write it carefully. Yeah. Okay, so this is the map function. Okay, so wherever there is no or yes, okay, so I have mapped it to the true false, right? Okay, see here you can see international plan, yes no yes no yes no. I have marked yes to false and okay. Why different? Because the series is different. Okay, here I have performed different thing. The numbers, just check the number. Okay, 0 1 2 3 4, right? Df dot head. Let me write this. So now let's compare. Okay, why it's coming? Because I have already performed that thing. So we'll go to here. See, no 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 no, yes yes. Now you can see here false false false, true true. So for no I gave false, and for the true, for the yes I gave true. Fine, this is the mapping. This is how you can do the mapping. Okay, so now let's do df equals to, same thing can be done using replace as well. There is one more function. Okay, let me give you the name, stack replace. Dot replace, then voicemail plan. Oh, sorry, my bad. Plan D. Okay. Fine now. Yes. Then df dot. Okay. So what I took, voicemail plan. Right? Same. See, true, true, false, false. Because here, if you will see, I have write D. D equals to this. Again, you have to write no to false and yes to true. The same I used here, D. No need to write again and again. Fine. So now let's see how to do grouping. Okay. So first, the group by method divides the grouping columns by their values. Okay. First, let me write this grouping. Okay. So here I will write columns to show equals to total day minutes, right? Comma total if minutes, comma total night minutes. Okay, then df dot group by, then here I will write Chan, then here I will write columns to show dot describe, percentile. Fine. Where is it's empty? Fine. There is error. df.group by Chan. Can different describe got an unexpected keyword argument percentile? Okay. Fine. It will be percentiles. Yeah. So this is how you can do the group by with a churn. Okay. So what I did. So let me explain the steps. So first, the group by method divides the grouping columns by their value. Okay. Then they become a new index in the resulting data frame. Then column of interest are selected, column to show, this column to show. Okay, so if column to show is not included, all the non-group by classes will be included. Finally, one or several functions are applied to obtain the groups for selected columns. So here what I did, we group the data according to their values of the churn variable and displays that of 3 columns in each group. Right, these 3 columns in each group. Same. Count means standard deviation minimum 50% max. Count means this. Okay. So this is how you can do grouping. Fine. So if you want to summarize the table, okay, suppose we want to see how observation in our sample are distributed in the context or two variables, churn and international plan. So to do so, we can build the contingency tables using the cross tab method. I will show you. Okay. So here I will write summary table. ed dot cross tab. Then I will write here data frame df churn comma df international plan. Okay. So this is the true false. The summary. Okay, we have this much true, false, 0 from the international plan, and the 41 are this much. Okay, for one, there are 346 and 137 true. Right. So this is how you can perform the summary table. Right. You can do for the more also. So now let's create the pivot table. Okay. So let's make the tables. Stack pivot tables. Okay, pivot tables. Fine. So I will add df dot pivot table. Okay, then I will write here. Sorry. Yes. So here I will write total day calls, comma, I will take 3 column total eve calls, comma, then total night calls, comma, then area code. Okay, comma, then aggregate function equals to mean. Okay, I'm using mean. Fine. So this is pivot, you got the area code and the mean of particular this thing. Right. So data frame transformation. So let me explain you first this pivot table. Okay, before moving forward. So so now we can see the most of the users are loyal and do not additional services. Okay, international plan or the voicemail. So this will resemble pivot table to those familiar with Excel and non, of course. Okay, so here the values are the list of variables to calculate stat for, and the index, okay, a list of variables to group data by, okay, area code, okay, and the aggregate function is what stat we need to calculate for the groups. Like we can use sum, mean, minimum, maximum, okay, something else. Okay, so here I have used the mean, right? So now let's predict the telecom churn. Okay, so now let's see how the churn rate is related to the international plan feature. So we will do this using cross tab contingency, already saw, and also through visual analysis with Seaborn. I've already told you with Matplotlib and the Seaborn, Pandas is crazy. Okay, so here I will write predicting telecom churn. Okay, so here I will write pd dot cross tab df churn, okay, C is capital, churn, comma, df international plan, comma, margin equals to true. Okay, okay, sorry, my bad, it's margins. Yeah, okay, we got the pivot table here using cost tab. So I will import here, import matplotlib for the charts. Matplotlib dot pyplot as plt. Then I will import Seaborn. Import. Just remember to install all these libraries. Okay, you can use pip install Seaborn and pip install NumPy, pip install Pandas before using it. Seaborn as SNS. Then for the graphic retina, I will use config inline backend dot figure format pursue retina. Okay, then here I will write SNS dot count plot where x equals to x-axis I'm giving, okay, international plan, comma, let's set the hue equals to churn, then comma data will be df. Okay, see, we have the counting of using international plan and the hue is churn, okay, 0 and 1. Fine. So we can see that the international plan, the churn rate is much higher, which is an interesting observation. Perhaps the large and the poorly controlled expenses with international calls are very conflict. Okay, so now let's take a look to another important feature, which is customer service call. Let's also use to to make the summary table first. So for that I will do here pd dot cross tab df churn, comma, df customer service calls, comma, margins equals to true. Okay, yes, so again I have made the summary table for the customer service calls. So now what I will create SNS dot count plot x equals to customer service calls where hue is chan, then data equals to df chan. Yes. Okay. So this is how you can create the charts using pandas and the c1. Fine. So therefore predicting that the customer is not loyal, churn equals to 1 in the case of when the number of calls to the service center is greater than 3 and the international plan is added. Okay. So this is how you can do data analysis using pandas. Okay. Web scraping is a powerful technique that allows you to automatically extract data from website, turning the vast amount of information available online into something you can easily analyze and use. Whether you are gathering data for research, building a dataset for machine learning project, or just curious about how websites work behind the scenes, web scraping is an essential skill to have in your toolkit. On the other hand, Python is one of the most popular programming languages for web scraping, thanks to its simplicity and the wealth of libraries available. In this video, we will explore how to use Python to scrape data from websites, and we will dive into practical examples using Python libraries like request and beautiful soup to fetch and parse web content. But it's not just about the code. Web scraping comes with its own set of challenges and ethical considerations. We will talk about how to scrape responsibly, respecting the rules set by websites, and ensuring that your scraping activity don't negatively impact the sites you are collecting data from. So by the end of this video, you will have a solid understanding of how to start scraping data from the web using Python. Whether you are new to programming or looking to add web scraping to your skill set, this video will give you the knowledge and tools you need to get started. So let's jump in and see how Python can help you unlock the full potential of the web. So here I am using this Google Colab for the web scraping. Okay, you can use your own like Jupyter Notebook, Visual Code Studio, anything. Okay, so here I will write web scraping using Python. Okay, then here first you have to install some libraries like request, and you have to install beautiful soup, and you have to install that pandas, because we will create one data frame and we will save it, then we will check our data. Okay, and you can install some basic Python libraries like NumPy and all that. Okay, so here first I will import request. Okay, then I will write from bs4 import beautiful soup. Okay, soup. Then I will write import pandas as pd. Fine. Then now what I will do, okay, let's see what is this request and all the thing. So request is an HTTP client library for the Python programming language. So request is one of the most downloaded Python libraries. Okay, with like more like over 2000, not exactly 2000, sorry, 200 or 300 million monthly download. Okay, so what it does, it maps the HTTP protocol onto Python's object-oriented semantics. And here beautiful soup. So beautiful soup is a Python package for parsing the HTML and XML documents, including those with malformed markup. It creates a parse tree for documents that can be used to extract data from HTML, which is useful for web scraping. Let me run it. Here our second step will be define the URL and the headers. Okay, URL and the headers. So URL, okay, from where you want to extract your data. So I will write here Simplilearn, then this. Okay, let's open this PMP certification. Okay, let's cut it. Yeah, so here I will write this, and headers equals to So these are the headers. Okay, so like in which device or you are working on, which browser you are working on. So these are for the headers. So now what I will do, I will send a get request to the Simplilearn page, okay, to this URL. For that, right, let me write is sending get request. Okay, here write response equals to requests dot get, then URL comma headers equals to headers. Okay, let me run it. Okay, working fine. So now let's check if the request is successful or not. For that, if response dot status code equals to 200, then soup equals to beautiful soup. Okay, then response dot content comma HTML dot parser. Okay, here, so here I will write codes titles. Why? Because here I'm initializing the list to store our titles or whatever the things are. Okay, basically the data. Okay, why I'm writing course here? Because this is again course page, that's why, nothing else. Okay, here I will give the empty list. So now we will find all course titles based on the actual HTML structure. What is HTML structure? You have to go to the page, right click, then inspect. Okay, according to this HTML structure means what is the class name, what is the this PMP certification is which heading, H1 heading, H2 heading, which heading it is. Okay, so let's see which heading it is. Okay, this PMP certification training H1 heading. Okay, just remember H1 heading. So here I will write for course in soup dot find for H1. Okay, then title equals to course text dot strip. Okay, then here I will write course titles dot append title. Okay, now what I will do, I will check if any data was extracted before it not. Okay, I will write if course titles. Here I will create a data frame, df equals to pd dot data frame. In this I will write course title. It will be our that column name. So for I will write it course data. Okay, then course titles. Okay, then here I will write df dot to CSV, then just create Simplilearn.csv. Okay, so our data will be saved in this Simplilearn.csv. Okay, CSV. Fine. Here what I will do, I will write index equals to false. Print data, and data is saved in CSV. Simplilearn.csv. Fine. So here I will write else print web page. Okay, write field to retrieve the web page. Okay, that's it. Let me run it. Okay, if response or status group, response object has no attribute, status code. Okay. Okay, title. It is text. Some minor spelling mistakes are there. Okay, df.field. Sorry, my bad. Again. Okay, sorry. D will be capital, F will be capital. Yeah, so now you can see data is saved in simplilearn.csv. So what I will do, I will write data equals to, everyone know how to read CSV in Python. read underscore CSV. What was our file name? Simplilearn.csv. Okay, let me copy paste, run it, and then find data. Okay, PMP certification training data is fetched. Okay, here you can see H1 we gave, and that's why PMP certification training came. Let's take what's in H2. Okay, in H2 there is leading premier PMI partner, something is there. Okay, I will change here H1 to H2, then I will run it. Okay, fine. See, leading premier PMI. Okay, let me make it big. Yeah, so now you can see course data we mentioned. So if you will see, this H1 didn't come. Why? Because we have mentioned H2. That's why. So these all are the H2. Okay, so what is this? I don't know. Okay, this is a time series graph. This is Google collecting. Okay, so this is how you can literally retrieve your data from any website. Okay, just remember that some websites don't give you access to their, for their scraping, just like Amazon don't give. So you have to use at that time API, and this is not ethical also to use someone's data, okay, without asking or whatever you. Thanks for completing NumPy Full Course by Simplilearn. You have gained valuable skills in one of the most in-demand programming language out there. If you liked the video, do hit the like button and notification. Thank you.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.